We're going to get started here in a couple minutes, just letting everyone know. We are, a couple minutes away. All right, so we are huddling back up. Seth, it looks like you're there. I see your screen moving around, slides and such.
All right, sorry about that, guys. I'm dealing with basement flooding of all things during the middle of training, so trying not to let it affect too much. So anyway,
Yeah,
I'm back
I didn't
now.
want to say something earlier, but we have to. Since you said it, we were trying to do everything as normal, this morning, and if it seemed like a little, we were just all of a sudden Seth is dealing with like a basement that flooded, and we're trying to keep the course going and be professional, but he's dealing with this horrible situation while also training. So sorry, man.
It's okay. We've got the contractors here now. They're drying it and cleaning it, so we're good. We can talk about source code now. So yeah. Anyway,
Nothing like adding. Not that training is super stressful. Just we're pretty familiar with the topic, I'd say, but yeah, just that definitely training's not necessarily easy either. And then you throw in that. Oh, I'm sorry, man. That's rough.
that's okay. Let's see, where are we at here? Okay. So Rufus, okay, we've done mapping. Let's get to authorization functions. We've already talked a lot about authorization functions. You've already just started to make notes about it. We notice it when we did the mapping. This kind of goes hand in hand with finding out what routes exist. I mean, realistically, what we're trying to do is figure out what other controls exist for the endpoints. It's not always just the endpoint itself, but how the data flows to the endpoints is very important from a security perspective. So we want to know what it is before we start looking into vulnerabilities associated with it. So that's why we call out how users are identified and how are they authorized to perform certain actions. And yeah, so anything else there? And
I think that we can go in a little bit more in depth on that note here.
Mm-hmm.
Yeah.
So we're again, like Ken looked at patterns and anti-patterns before with SEMGREP. We're going to do the same thing, looking for sessions, like how sessions are used, if it is just tokens or JWTs, like how, what are the authenticated user, what are the different roles, where does the role check actually happen? Sometimes you'll see code like lambdas written into attributes, right? Or decorators to check for a user's role? Or is it something else? Is it embedded in those different GET requests or the different functions that are in the controllers themselves? At this point too, you're going to start to identify what could go wrong if the authorization functions don't exist. Whether that is the IDOR, like the insecure direct object reference, where we can pull someone else's data based on an ID parameter, or cross-site request forgery, or just what's available. Can I get to places in the application that I shouldn't be able to? But again, we want to hold back a little bit. We just want to identify what the functions are and where we kind of see those possibilities. And then we'll go down the rabbit hole when we get to the authorization checks.
Yeah, no, I mean, in terms of the ways that you can determine someone's identity, we've seen this go wrong in a number of ways. I mean, from stuff as basic to literally based off of the parameter that somebody supplies. Like, that's bananas, but that's totally happened. And sometimes that parameter is just like a numeric value, and it's like, oh, that's the user, right? Like, that's the insecure direct object reference, or IDOR. You're going to hear us call it IDOR because it's way shorter to say that than insecure direct object reference. But anyways, so that's one way. We've seen ROT 13. I mean, again, speaking to when Seth and I have worked together in our previous stories from that. I mean, early on in our fishnet days, we had a client who did ROT 13 on their PDF names, and that was it was like, why are the last 3 or 4 characters always the same? Well, they're ROT 13 for .pdf, and all you got to do is understand the file name, and then you've got your file that you want, and that's literally the authorization function for get file, right? I mean, in terms of things that can go wrong, there can be flawed lookups, like literally looking up something in the database and passing in user data, and there being maybe like injection or just some other way to modify. Like a good example of that is with in-memory databases. If you can control the set and get keys, that means you can control what you put in there and who it's for, or like, how it's referenced later, rather. So imagine like what I mean by that is very simple. Imagine like a JSON hash. You have a key, which we'll say is like, I don't know, A, and then it might have two values, which are B and C. Well, that's essentially what we're talking about, is that A might be the key. So replace A with like user ID. If I could set and get user ID on some data that's stored in an in-memory database, pretty bad, right? So there's all kinds of ways this can go wrong. And you see CSRF mentioned because CSRF is an authorization function. So that's why we list that out.
Yep. So you may have to dig a little bit into the documentation for frameworks on, or for Rails or Django, on how CSRF happens or how it's supposed to be used. You'll want to pull that out of whatever web framework you're dealing with. If it's not a web framework, then you probably aren't as concerned with it, but you should still be aware. So. Yes. Okay. So is this my story? Okay. Yeah.
This is our mutual story that starts in 2018 at CactusCon, or 2017. I can't remember, one of the two. I was sitting in a hotel room talking about code review stuff.
And I was talking, like, we were talking about authorization issues, specifically with .NET. And I ran across this years ago where I was testing an application dynamically. And I found that when I wasn't, if I wasn't logged into the admin portal, it would redirect me back to the login page, which is pretty standard, right? But the problem was exactly, this is what you would normally see, right? Example.aspx, like we're looking at a burp log here. The length comes back, it tells me, hey, example.aspx, we're sending you back to the login page because you're not logged in. But as I reviewed the burp log after I was trying to hit all these pages, not being logged into the administrator account, I was seeing stuff like this. I was seeing a 301 redirect, but I was seeing length of just massive amounts of data that were coming back from the application. And if I viewed this request or this response from the application, what it actually turned out to be was the page itself that I was requesting rendered in full behind the scenes. And I was like, what in the hell is going on? So we get to, redirection and authorization issues as we're building out this course. And I was like, hey, Ken, there was this time in .NET where I was dealing with this application, and this is what I was seeing. And I found with Burp that I could just basically ignore the status and the redirect's call and just change it to 200 OK. And I became the administrator in the account. And I was like, it was super cool. And Ken was like, wait, I know why this happened. Right. And so what is it, Ken?
I had a similar weirdness occur, and I was like, why is this happening? It shouldn't be happening. A response length shouldn't be that long. It should be a short response length and nothing else. And similar to Seth, just whenever the response came back through the proxy, I was just omitting the location header, which, tells the browser to redirect, and replacing it with like a 200. And yeah, I was just able to use the application as normal because 301, yeah, sure, it redirect, but it like still renders stuff. So next slide. So what had happened was there is a nuance, another weird nuance to be aware of. And when you pass a redirection in .NET, and this, I'm sure this has changed, or maybe it hasn't, I don't know. But at the time, when you pass in a false or true as the second argument, so the redirect, the first argument is just the URL that you want to send somebody to. That second argument, false or true, determines whether or not execution will stop. Now, this is an important concept because we're going to show an example of that here in a second. When execution does not stop, and it could be on a redirect, it could be on an authorization function in general. Like an authorization function needs to stop execution if you are not authorized. So in this case, again, if you pass in a false, it means that you'll get the redirection, the location header to tells the browser to redirect, but it'll still render everything and it'll allow the execution to continue. So what that means is, even though you're going to get a redirect location header off to somewhere, the rest of the call out to like build the HTML template to then respond with variable data that's, inside that HTML, basically to create an HTML page and actually, view like whatever admin portal page Seth's talking about. You need all of that, meaning the next logic that occurs after the authorization filter to then execute in order for that to happen. So if you ever pass in a false here, you will effectively have no authorization whatsoever. Really, it's just all for show, because anybody that knows what they're doing is going to be able to like change that to a 200. This is another example of a framework nuance. And on the next slide, we go a little bit more into that. So
into this?
Yep. So, okay. Yes, sir. So, and actually, I'm going to ask for some request remote control.
No, deny.
No, denied. Yeah, so this is an exact example of that. So, inside of, again, the very opinionated Rails, you see this protect from forgery statement. And that is one that's on at the application controller level, unless an individual controller has done an exemption. So, because you can definitely opt out of something like this. I should explain, in Rails, an application controller is the base controller from which every other controller typically inherits. Now, you can override that, you can change that. And you can, like I said, you can even say like, hey, I built this new controller. It automatically inherits from application controller. But guess what? Any of that like protect from forgery stuff, I can opt out of it. In fact, anything that's declared as like a helper method, essentially, which even though that doesn't, on line 4, you don't see protect from forgery as a helper method, it's just built into the framework as like an accessible helper method. Anyways, my point to all of this is, that next on line 9, when you see with exception commented out, that's actually extremely important. So someone that I now work with again, and Seth and I worked with together, John Poulin, or Forced Request is his Twitter handle / GitHub username. But I work with John. Seth's worked with John. What John had found with Rails was pretty interesting. He found that for some reason, in an assessment he was doing, that the CSRF check worked sometimes and then not other times, and it even would say like, hey, it would even log like, hey, there was a CSRF bypass and issue, but guess what? They were still able to update something using that endpoint. And it was pretty confusing because there was nowhere where this protect from forgery was opted out of and all of that. At the time, there was no such thing as with exception. This with exception actually exists because of John's research. So what we had found was, or what John had found was that when protect from forgery found that a token either wasn't valid or wasn't submitted on an endpoint that had CSRF protections on it, what it does is it first clears out the cookies. And these are the Rails built-in sessions it clears out. You can actually add custom cookies with Rails, and that's important to note, and that's why this happened. So it clears out the Rails session, and then the expectation is the next check that you're going to hit, which is like, a current user type check, meaning it just validates that you have a session, that it knows who you are, that you're all kinds of things that you can bake into that, right? So, but that's dependent on those Rails sessions. So what he found was essentially what I'm saying is it would clear out the Rails sessions, but because this application used a custom cookie and not the Rails session, the execution still the execution still occurred. It was another situation where, yes, it recognized an error. Yes, it killed off the session, expecting that would mean that the person wouldn't be authenticated anymore. But that wasn't the case. Their authentication relied on custom cookies. And this is a scenario. And by the way, now if you uncomment that with exception, not only does it clear out the sessions, but it actually also just raises an exception to actually kill the chain of execution. And that's what you're looking for in authorization functions. You're looking for methods that are built into the framework, and you need to look up how they're called, like a redirect or a protect from forgery. You need to understand how those functions actually work. And also, you need to make sure that any authorization function actually stops execution at the time that some check that's important fails. So that's just I know that's a lot, but I think it's important to give you this context because these are absolutely critical elements of author. Because remember, right now, we're not talking about like identifying authorization functions. We're talking about like issues in authorization functions. So yes, this is one thing that you need to be aware of.
Yep. Yeah, and I mean, I wish there was a better place to say, hey, always go look here, but there just isn't, right? Like, so you have to get to know the framework that you're dealing with. I mean, if we go back to this one for a minute, right? Yeah, I mean, developer documentation, like I take, I get annoyed at times at how like unresponsive it actually is, or how like hard it actually is to figure out based on what the developers put into the documentation, right? So end response, like whether it's like a positive or a negative, should I be putting end response in there as a false? So it does end or it doesn't. Like I have a hard time reading some of these just based on the documentation in and of itself. But that is still like for the latest version of .NET, ASP.NET, Ken, that redirect still exists. That's still an issue. But anyway,
I think I'm going to be dealing more and more with .NET. So I'll
you'll let me know
already
how that
seeing
goes.
it with having been acquired by the Borg.
Yeah, exactly. All right. So from a checklist perspective, just looking for authorizations, hey, How is user access controlled? Is it session, token, basic authorization? Is there something else that we need to be aware of? Do they have to do do they have to wear a unicorn mask to get in, right? Like, what's going on with the application? How is it actually controlled? That's what we're trying to identify here. Yeah. Identify its purpose. Yeah. Go ahead.
No, I was going to just add here. Sorry. This is the one that we kind of talked about in the previous, like, understanding authorization decorators and whatnot. But like, I think it's just important to note that it literally could be so many things. And given your exercise that's coming up here in a moment, or momentarily in a few slides, I want you to be aware of the fact that sometimes the authorization decorators do not live in the source code. Repeat, do not live in the source code of the application that you're using. Sometimes you need to go into the dependencies, find out which of those dependencies might be authorization dependencies, and then go into those dependencies, and that's where the actual authorization logic that's being called from within the application source code actually is defined. So I just want to repeat that one last time. Inside of an application source code, you may see an authorization decorator referred to, but you don't see it defined anywhere in there. This is your time to go look at a gem file, to go look at your, in requirements.txt in a Django, or whatever your NuGet for .NET, or POM for Java, whatever it is. Go look at your dependencies, figure out which ones are authorization related, and then go do your homework. I think I've done enough there to set you up for the next exercise.
Yes.
/ real world, like, stuff you're going to come across, hopefully.
Functions checklist. Ken's talked a little bit about this, right? Like, we're not going to dive again too far into it after we identify it. But like, these are kind of the things that you've got to be aware of: is the framework nuances, the insecure timings. We'll get into the authentication and authorization flaws and vulnerabilities themselves. But realistically, think about what, like, when we're identifying those functions, start to think about the risks that are associated with them, right? We're just trying to figure out if there is a risk to any of it, because some of those functions could be innocuous and we don't need to worry about them as much. But at the very least, we need to know that they all exist and what's going on with them. So think about what's going on, because that's going to go in your list of risks at some point. Okay.
All right. I want to point something out here. Two things, actually. So once again, I made a comment about authorization functions and where they could potentially live. I want to reiterate that. Secondly, remember, when you're doing your mapping, not only are there framework nuances with, like, authorization functions that we kind of just walk through, or like redirection functions inside of authorization, whatever. There's framework nuances also, don't forget, inside of routing. So if you're not familiar with, say, Rails routing, since this is going to be a Rails application, I would invest, because we're going to give you like a good amount of time, like 20 minutes for this exercise. I would invest just a couple minutes on looking at looking at the routes, and then determining if there's anything that like stands out, basically. So yeah, I guess that's all I can say.
Okay. All right, so we're starting with a new application. Once again, make a new copy of example template.md, figure out the commit number, figure out the tech stack, the business purpose, do a small risk assessment, and then jump into mapping the routes. It is Rails at this point, Skia Rails. So there is a routes.rb file. You can try and run rake routes. Depends on how familiar you are with Rails. If you want to run down that effort, I'd probably advise you to jump into the code itself. But then you've got to get into the authorization functions. That's the point. We want to do everything that we've performed previously and move to the next step, which is those authorization functions. So, cool. Okay, so what we'll do is we'll take until, sure, Ilya, let me drop that GitHub link for Skia Rails. Is that the one you're looking for?
Oh, yeah. And one thing that might help is to also reference the as you're going through documentation. I want to just mention that I talked about it before with tech stack and versioning, but I think it makes sense to understand which version of Rails you're dealing with to look at then the associated routing documentation, because even that can be very different between different versions. So trying to set everyone up with as much for success here as possible, but yeah.
Yep. It's very true to life. You're going to bang your head against a wall. Yep. Anyway, so let's give them until 2:30 Pacific, Ken. So that's 21 minutes from now. Feel free to jump into Slack or chat if you have a question or you see something that you want others to know about. But otherwise, go figure out ski rails, and we'll talk shortly. everyone getting through it? Sort of. That's good, Richard. Sort of is probably where we want you at. If you could do it already, you wouldn't be here. So, yep, good. Reading about devise. That's a good place to be.
Yeah, and I'm happy to give people a few more minutes than just that to like dig in if they, because this is not an easy one.
Mm-mm. And you can blame Ken for this one because he's the Rails guy. So you can blame me for later ones, but I'm just going to shift all the blame to Ken today. So what's the verdict? People want more time, or should we bring it back together? Together? Yeah, it might be a little bit easier. All right. So first things first, tech stack, business purpose, and then any risks. So tech stack wise, obviously we know it's Ruby on Rails just from the name, but could anyone ascertain a business purpose? Not from the README, right? You could vote, blog, yeah, cool. So it's just a simple app. Um, has articles, and you can either like or dislike an article. So pretty simple mechanism for some sort of social interaction, but nothing too complex, not like comments or anything like that. Did everybody find the routes? Didn't look like there was a bunch of them. So it looks like, yeah, there's the devise, whatever devise for users means, right? So we're using some sort of devise authorization for users. But otherwise, the app routes are pretty simple, like articles, creating articles, getting the new ones, editing. Interesting. Posts, patch. All right, update, destroy. Easy enough. Did anybody successfully run rake routes? Yeah. Ken, do you have that queued up? You want to show what it comes up with?
Yeah, I am. Sorry, I'm having a little issue myself over here with the VM. So, of course, go ahead and go on to the next slide.
Yeah. Okay. So you did. So Mike, you did rake DB setup, right? Okay. So that was because you were using Ruby version 2.6.3. Gem file specified actually 2.3.4. So the gem file is associated with that version of Rails that Skia Rails was built against initially. So it doesn't mean that it won't work with version 2.6.3, but there might be some changes, especially those major versions, 2.3 to 2.4 to 2.5 to 2.6. There might be something, but it could still function. Let me see if I jump into mine. Yeah. Because I have to do bundle install as well. Look at that. Yeah, so we'll let Ken troubleshoot that while we jump to the next one, right? Oh yeah. Okay. So I know we have authenticate user. Did anybody see?
Oh. Hey, I'm good. Sorry. It's just it was like a weird. I was having a weird it's that bin bash login thing. That's what it was causing me issues.
Oh, yep.
Yeah. Anyways, I'm sorry. I want to share. I'm gonna go ahead and share my screen now.
Okay, go for it.
Yeah. The VM, because my backup went nuts too. I don't know what's going on today. It's just been an odd day. Anyways, let me share my screen. It is going to be here. All right. So on the note of, on the slides, let me pull those up real quick. So first of all, yes, this is an issue. I'm going to speak to this just real quick. And I'm sorry, Seth, if you spoke to this. I'm just going to reiterate.
Nope, I haven't yet.
Okay, I was a little focused on getting my system up and running. Anyways, all right. So firstly, this was purposefully not a nice thing that I did, but I did try to give everyone information that, hey, this authorization function may live somewhere else. And I know you mentioned somebody was looking in the documentation for devise. That is awesome. That is what I expected. Like I said, if you cannot figure out, in this case, authenticate underscore user, bang, is not defined anywhere inside the source code. If you can't figure it out, it's time to start figuring out which of your libraries you've included, or the applications included rather, that has this in there. So there's three sort of approaches here, and I'm going to walk you through something that you may not have seen before. I hope this provides some value, and I like showing it, not because I think you're going to specifically remember every part of this, or that you might do a ton of Rails reviews. It's to explain that this is something that sometimes just exists as an option inside of some frameworks. And I encourage you, if you have a runtime environment, meaning especially if you have locally, if you have the ability to install the application, which is, 50. I mean, I don't know. It just depends on what type of work you're dealing with, but especially more modern tech stacks, they give you these types of options. So before, let me just get into it. So if you can run an interactive like Rails, in our case, Rails console actually allows you to run code. So this is actually the application running, and I can go inside of it and do things. So like for instance, I could say, hey, that application controller, I'm gonna do a .new, which is like just spinning up a new instance of application controller, and I'm going to interrogate it. So that method is asking, hey, for this authenticate user, give me this source location. And when I do that, it tells me where this actual method is defined. It's kind of a cheat sheet. Obviously, I didn't really, put that out there, or it's not cheat sheet, a cheat or a hack. But if you have interactive runtime environments available to you, like I said, more modern frameworks have these kind of interactive consoles that you can actually ask the application questions and, figure out like where things are defined and how they're supposed to behave. And I use this a lot, especially like when I'm trying to figure out if a regex is like my bypasses for a regex, if they'll work, I'll oftentimes go in here and actually like play with the defined methods and send it data on the fly in this form. Anyways, now I know exactly where this method is defined, and I'm going to go ahead and just open that file then. But I'll probably do that. Yeah, I can do that here, I guess. It just really looks terrible and hard to read. Yeah, why not? I'll just do that. All right, so I'm going to go down to actually right about here. So now this is why it can be frustrating to review a language you don't have a lot of familiarity with. And I'm not going to say that you're going to get perfect results if you're not super familiar with more intricate uses of a language like you see here. Doesn't mean your assessment won't be good, just means that it helps to have obviously the language. The more you know about a language, the better. So here we have this class eval, which basically is this is basically a giant string. And you can actually do authenticate underscore whatever table you want to go with. So you can go with authenticate underscore user, authenticate underscore admin, authenticate underscore person, whatever the devise model you're going, like you actually declare which model is going to be like the identity, like the individual or the group or a user, whatever the model name is. This is essentially what this is doing. So all you need to know here is that this is where the method is defined. It's doing some crazy meta programming. If you haven't dealt with meta programming yet, congratulations. You're a very lucky person that doesn't have to deal with that crazy stuff that isn't super fun all the time. But this is, meta programming, which just means code that writes code. So at runtime, this gets interpreted and changed around and blah, 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 blah. But the bottom line here is that you do have the ability with some of these frameworks to go in, ask questions if you can't find anything in the documentation, which brings me back to our slides real quick here. Sometimes it comes down to just having experience with the framework in the library. Sometimes that's just part of it. It makes it go faster, that's for sure. But, more often than not, you're not going to have A, B, you're going to only have C, which is like, no previous experience with it and only access to source code. And that's where, like I said, you start looking at the documentation, you start doing some homework. Has anybody else seen something like this? If you don't get answers, then it's really time to dig into those libraries and figure out like, and honestly though, like if you're really stuck and you have the ability to just ask somebody, that's totally normal too. It's not weird at all. Like, yeah, it'll just speed things up. Asking questions doesn't make you look like worse at your job or something. It's totally normal. So anyways, let me hand that back over to you, Seth. Control over to you if I can figure out where the Zoom controls are at. Or can you just take over? Because I don't know, like this Zoom thing is hard to see where the controls are at.
Yeah, I'm taking back over. That's fine.
Cool. Thanks. Sweet. Thank you.
Yep. It was okay. So that's where we were at, right? There was also some other interesting routes that get defined, but again, it goes back to Rails being this meta programming language, or Ruby being meta programming, and defining things easily for developers. You'd want to investigate more of those as we go down the rabbit hole. But the biggest thing here is knowing what those functions are, right? What those authorization functions are. But we also run into another framework nuance with CSRF in here, and this is one that Ken has like a lot of experience with, or it popped up. I think it was during your interview, right?
Oh, you're going ahead. You're skipping ahead. No, yeah, you're right. So this is a this is
Did I
actual
skip
thing that
ahead? I'm
happened.
sorry. Yeah.
But first of all, my question here is, did anybody actually figure this out? Did anyone understand the vulnerability here, the framework nuance? Let me stand up while I wait. Convert. This is one of my favorites. Yeah. Reinforces a couple things. Nothing so far. Check other Slack. Chat. No, nothing.
Mm-hmm.
Didn't get there. Was trying to figure out device. Yeah, I'm sorry. Like I know it's not easy, and that's on some routes look funny, but that's okay. No, but that's actually perfect. Ilya, that's perfect. Yes, Dustin. Nice. You figured it out. I don't know if this counts, but I found a foul with emails pastors. No, that's and a good Parks and Rec reference. Yeah, we're Ron Swanson fans for
Yes.
sure. Yeah, so two things here. So for one, Ilya, that's awesome. That's instinct. That's just something looking different. This is actually important. It sounds silly, but anything that's outside what I've learned over the years is that your brain establishes patterns. Everybody's does it differently, but our brains establish patterns. And anything, and we talked about anti-patterns back a few slides ago, but this is an anti-pattern. It's something that didn't follow along. You never saw action, : action, anywhere else in that routes file. It's stuck out and it looked funny, right? This is a good example of where, okay, we know we're not experts in this routing and this framework and how it routes and all that stuff. We do have the ability to go and look at documentation when things look odd. This is a perfect example of figuring out what exactly does action do. And, Dustin, you called out the ID action bit there, right? Ilya, you may not have, it may just looked a little weird, something like that. First of all, the whole colon thing is more of a placeholder. You see that's actually very common in most like routing, routing in general for most frameworks, having a colon. That's not too crazy. But when you see something like colon action and it doesn't really, there's no other colon actions, it should make you pause. And that's exactly what happened in my scenario, which I'll talk about here in a moment. But anyways, the interesting thing here, and I am once again, I feel like I'm a meme at this point. I am once again requesting remote control of you, Seth.
Yeah, you got to put on a pair of mittens for that, but okay.
Exactly. I'm going to be the new Bernie. All right. So this line right here is problematic. It's very problematic. All right. So it is a GET request. And the idea here is you put in, in the URL, literally like example.com /articles /1 or 2 or 3, whatever the article ID number is, / you can put nothing in, you can put in edit. And if you place into the parameter edit, it's going to go to edit article. But the interesting thing about this action declaration is it's actually in the Rails documentation that if you put that value in, whatever you put into the URL there that represents action, if it matches the name of a defined method inside of that controller file, it's going to route that request not to the edit article in that case. If I put in, let me just give you an example. If I put in /articles/1/show, it's going to immediately route it to the show method that's defined in that controller. That is because it's trying to do everything. It's being a meta programming function. It's a specific weirdness in the later versions of Rails routing. And this is definitely problematic. And I'll explain that now. So chart. All right. So if I can. All right. Here's a practical version of what this should look like, right? This is the sort of like, or not what it should look like, what the attack would look like. So let's say there's a vote method. And this was the case, by the way. This is all based off of an exercise that I did to interview for GitHub. Actually, they built a vulnerable application. It was based on some vulnerabilities that they had discovered, and like decided to like, you know, after obviously after fixed, like roll it into their assessment. To you have to do like a few assessments to actually like, you know, get through the interview process. And so this was part of that. And what had happened was I was doubling back on after the assessment, and I noticed this whole like action declaration. I was like, what is this? Well, there was this vote method that was inside of the controller, the articles controller, and that vote method was in the route file defined as a post request, like it should be, right? Because you're doing something like updating a database, a CRUD operation, and you're submitting a vote. And like in Rails, CSRF protections only exist on dangerous methods, right? It doesn't exist on like a GET. There should be no reason to have a CSRF protection on GET. So anyways, vote method's defined. It's set up to be routed via post request. It's got CSRF protections on it. Everything's great. You wouldn't be able to CSRF attack somebody, right? Well, because of this flaw where you've got this, here, let me click on it. Because of that declaration right there, if I put the word vote in there, it will go to that vote method that should be post, you know, CSRF protected because it's a post request. But again, because if you look to your left of that, you can see there's a GET declaration. I can send, what I'm trying to say is I can send a GET request with that, with this link at the top where it says articles 1 vote type equals like. So I can just send that GET request off. It'll bypass CSRF protections. It will, you know, use a route that was defined in a way that is not ideal, but not intended for this result to occur. And all of that's basically a combination of things, you know, doubling back. And I'm going to talk about that here in a second. This is sort of the story time of that, right? I went through, did my interview process, banged my head against the wall, found all the vulns I thought I could find, doubled back. This is why we talk about always doubling back. Went back through each part of the framework flow, and I was like, wait, again, looking at this routes, it looks a little weird. You know, let's dig into this. Had found that, you know, this vulnerability existed, that it was some weird way to bypass CSRF protection, since this is method interchange, by the way. When there's confusion and you can, something that should only have a GET request or should only have a post request or put request, if you can swap that around, you can oftentimes bypass the CSRF protections built into frameworks. And the reason is frameworks only expect to apply CSRF, and developers and security folks only need that applied to dangerous methods. But again, if you can cause confusion, if there's problems with routing, this is where you see method interchange issues crop up. And anyways, I just think that it stresses the importance of doing your homework and doubling back. And for me, that, you know, like working at GitHub has been amazing. And, you know, I can tell you if I didn't do those things and submit a fully fleshed out exercise, I wouldn't be working at GitHub right now. And it's been really good for me. So I'm very happy I'm there. So I would say, you know, follow my advice. These things work. You know, always, and again, always double back. It's so important. It's always important. Anything to add there, Seth?
Not necessarily, right? Like most of my doubling back on the framework nuance stuff happens towards, I mean, honestly, it's towards the end of an assessment when I feel like I've got my head around what's going on and have found some vulnerabilities. And then that's usually where I start to find like these nuanced issues. business logic flaws where I understand what's going on better with the application because I've been in the code for a few days, as opposed to other other vulnerabilities that exist. So yeah, but it's a good example of it. And yeah, let's move from there. Because that finally brings us to checklist and reviews, right? Up to this point, we've been doing our research. We've finally been we understand the application a little bit. So we're going to start digging into the actual vulnerabilities and how they manifest in code. But this does mean that we need to understand kind of the overarching security concepts that we're looking at for code bases. Instead of diving directly into this is how we code securely in Java, .NET, Rails, Django, Python, we want to think about it from a higher level so that we can identify issues that maybe crop up because of integrations, third-party libraries, developer flaws or developer tendencies, as opposed to just, hey, it looks like they didn't use strcat, right? Or strncat, right? Like in the case of C and C++. We want those higher level vulnerabilities and we want to identify them as quickly as possible. So that's the reason that we structure our framework around AAA, first of all. So authentication, authorization, and auditing, my favorite topic. And also kind of this CIA triad, confidentiality, integrity, and availability. We do break that one down into input, like input validation, cryptography, configuration, right? Like we've got some other things that we talk about there at a higher level. But the first three that we're going to talk about, the first three topics and vulnerabilities that we're going to identify are around authorization, authentication, and auditing. Right.
And by the way, I want to add in, you have access to all of these checklists. We're going to talk through them, but please don't feel like you need to memorize or write down any of this stuff. You have all these checklists in that handouts folder. Sorry, Seth. I didn't need to because I know sometimes you've got sometimes very studious folks who will just start, right? And it's like, don't do that. That's going to hurt your brain. Just listen.
Yeah. So if you go back to that handouts repository, you're going to see the generic checks in there. This is everything that we have in the list, and we use it as a baseline. So when I do an assessment and I'm doing a code review, that's what I start from, and then I remove and add things from the checklist based on the risks that I've identified with the application, right? So if it's an application that doesn't require authentication, people don't log into it, and it's just like a public API, guess what? I'm just going to drop those sections and we're going to move on. Or if I'm just looking at a library or something like that, there's different checklists that I add to or remove from that list. So it's in the handouts repository if you want to pull it directly. So first things first, though, we have AAA, authentication, authorization, and auditing. Why is it that we talk about these three? What are the differences between them? So first of all, if we talk about it in the traditional sense, what is the difference between authentication and authorization? Access. Ilya, what do you mean by access?
I'll just hop on the mic. I believe authentication is who you are. Authorization is what you can get into.
Perfect. And then auditing is what you did, right? Yeah.
Yep, logging. Yep.
Yep, logging. Yeah. So authorization is identity. Richard, you've got it there too. Identity verification. Michael, you did as well, right? Like who's allowed versus what permissions do they have, right? Authorization is what can you do? Authentication is who are you? Yeah. How do I validate what you did? Exactly, Chris. Good. So I think everybody's got a good reference for that. So I always classify like the OWASP top 10 or the SANS CWE into one of those buckets, right? It's interesting to talk about, right, like nuanced vulnerabilities and SSRF and, redirect issues, but they all fall under one of these overarching security concepts. So if I'm looking at code and I've already started to look at these authorization functions, it naturally flows that I'm going to look at authorization vulnerabilities that are associated with that. It's a good way for me to start picking apart the roles that are in the application, figure out how the application is authorizing users, whether it's doing it appropriately, or if it's missing in certain places. I've already got a list of endpoints that are out there. I know who should, like what should be authorized, where it should be authorized. I know if there's an admin section. I know if there's, admin functionality or manager functionality, because I've already enumerated out all those endpoints. So now we're going to see how is it actually implemented, and if there are flaws within those authorization functions. Right? So really, we're looking for role enforcement, right? Are those appropriate user boundaries there? We talk about, uh, horizontal versus vertical authorization or access control. So if am I trying to increase my privileges from unauthenticated to authenticated, anonymous to authorized, or am I trying to see someone else's data? I do have a list of vulnerabilities, I believe, in here. Yeah, these broken access control. Let me see. Yeah, the vertical authorization versus the horizontal. Let's see. Yeah. The first thing that falls into this is whether or not we've actually identified the roles that are associated with this application, though, right? If there's no authorization roles associated with it, it's going to be very hard to determine if it's been implemented properly, if a user should be able to see that data, if they have implemented those access boundaries properly, right? And that's where authorization comes into play. Vulnerabilities that we're looking for here: broken access control, OS top 10, like this is your privilege escalation, your MFLAC, right? Like, hey, there's allow anonymous turned on for this specific endpoint. Is that valid? Insecure direct object reference. Can I change an ID parameter from a 2 to a 3 and maybe see somebody else's credit card, somebody else's shopping cart, or their account information? Sensitive data exposure, like maybe I can retrieve a JSON endpoint and it gives me back more data than it should in an unauthorized manner. Also under this, mass assignment, business logic flaws. I mean, really, it's anything to do with authorization of data and functionality that we're attempting to enumerate and then identify the issues associated with that. Ken, what am I missing there? I know I'm missing something, right?
Not really. I think you're good.
Okay.
We talk about mass assignment later, so
Yeah,
I'm not going to touch on that.
Yeah, it's a good vulnerability, but it's typical to, or it's similar to business logic flaw as well, right? But okay, this is a spot the bug exercise, and yeah, we'll give you a minute. Everybody take a minute. This is Java, right? But there is a flaw here, and it is an authorization
Well, if you could go and get to where you can control the user ID that's being passed in, you could get access of any ID that you wanted to in that area.
Yeah. Yep. So, and that's exactly what's going on here, right? Like it's checking to see whether this like EAC user has the ability, like it's returning true if it's is view all applications. But it's checking to see whether that, okay, so it's like this check if application exists. Underneath that comment is where the problem pops up, because they're checking, they're getting the access control for the user that's being passed in based on the organization that you're logged in as. So I assume there's some sort of check to make sure that the user's in that organization. What we're not seeing is, okay, as long as that user ID is in the organization and has this is view all applications tagged on it and it's controlled, they're going to be able to see that application, right? It's going to return true here, even if the user ID does not match the request user ID, right? And that's exactly the problem that we're running into, is it's an insecure direct object reference, as long as that user ID value is in the same organization that is also being passed in, right? It never gets to the point to check whether or not the EAC user contains that application, as long as it is an administrator ID. If you passed in admin for that org that you're currently associated with, boom, you get access to the application and it's good. And this was, this actually is code from an application that we were looking at, and it was successful in returning and seeing applications that we didn't normally have access to with the logged in user, because it was pulling that user ID from the string parameter out of the URL, as opposed to pulling it out of the session object on the server side. So good call.
And this is an example of like, insecure direct object reference where, you could just pass in a value and just get a record return, and then the authorization check occurs on that. We talked about that earlier. And the way you would fix this, is obviously you tie this to a session or some token or something that like the user had to authenticate, receive a value that tracks their identity, that is not something they can tamper with. And that's the only way to prevent things like this. And we see this all the time in role-based, or rather, authorization checks, where it's like you think it's mostly secure and done well, and there's something like this where it's like, oh,
yep,
nope.
Yeah, and it was interesting to exploit this one, because the organization, like it was only specific user IDs that it actually worked for, right? So I could get the applications for those users within the organization that I was already in. And so I started to see stuff I shouldn't be able to see. And like, it's just it's kind of these edge cases that we're looking for. And I always, we go back to the gut feel when we're looking at source code. Usually when that pops up, especially as a developer who's put together applications in the past, that is usually an indication that you need to dig a little bit more, and you need to keep scratching at that itch until you understand why you have it, right? So Nathaniel, you instantly went to that arbitrary string input, and that's exactly where it starts. Is, wait a second, that's coming in as a string and not as a user. There's something odd that's going on there, which means it's user controlled, which goes down this other path of how, what's happening with that user. So that's a case of insecure direct object reference. Nice catch. All right, let's see what else is here. Okay, so we've got checklists here. We can talk through these. I think we want to push through more than one checklist today, so we'll probably kind of gloss over these as they are in the checklist. The generic checks that we're providing. But basically, we want, for each of the authorization functions that we've identified, we want to go through this checklist, right? To see if, non-privileged users can view, add, alter accounts. Like, we want to identify the endpoints that are sensitive to authorization and see if there's ways that those can be manipulated, or ways that data can be passed in. in the case of insecure direct object reference or these like horizontal access control issues, I typically go through a few sensitive ones and attempt to identify the patterns that are associated with it, right? If I'm looking at 1,000 different endpoints and they all have ID parameters, I'll know pretty quick if it works on one or two as I do a spot check, and I can use that pattern to run through the rest of them rather than looking through every single endpoint for insecure direct object reference, right? Disabled accounts, right? Like, is there anything that flags disabled accounts? Password protector pages, can you directly access those without authentication? You'd be surprised at the number of times that we find pages that are exposed that should not be, whether it's like an API endpoint that's only like JSON accessible, or the developers think that because they've logged in and they only get that, you know, one link after they've logged in, they forget that they need to add authentication or authorization on that endpoint. Higher access levels. Okay. So these checklists are in there, like we want to apply them to the authorization functions and to the endpoints where it makes sense. And then we can extrapolate that out across the rest of the application when we actually do the full authorization review. Okay, so that brings us to mass assignment. Ken, do you want to talk through mass assignment? Me too.
Nope, I give up. No, I'm just kidding. Of course, yes. I love mass assignment. And I love mass assignment because, well, it's an interesting, first of all, it's an interesting vuln, but it's one of the most, well, I shouldn't say that. Anecdotally, it feels like one of the most overlooked vulns, especially when developers create new frameworks. Like, we saw this early on in other frameworks, and then and I'll show and talk about an example here in a second of like how this presented itself in Node and Mongoose. But it's funny, it's like the same. Seth and I always talk about how like the same vulns just keep coming back around in different forms. And so mass assignment's no different. I mean, it's been labeled over the years as insecure binder vulnerability, insecure object mapping, mass assignment. I'm sure there's other terms people use, but basically what happens is if you can like create or update a record and it just accepts whatever data you give, then you're going to be able to change all of the attributes of a record, right? So what does that look like in practical terms? As I click through here, I can never tell if my clicks are working with Zoom. All right, there we go. All right. So what does that look like? All right. In this case, we took the entire body of a request and passed it along into the creation of a new user attribute. Now, that's an issue, and I'll show you why. Share my screen. All right. Here is a DB browser for SQLite. I'm just visually giving you some representation here. That's why you're looking at this. So let me expand this a little bit if I can. All right. So in this user table, this is inside of a database for RailsGoat. There's a user table, and it has different attributes associated with each record, right? Now, if I can pass into my request, let's say I'm signing up. I can't tell you how many times when I was doing a consulting back between the real prime time for this one for me, consulting wise, was between like 2012 or 2013 to like 2017, 2016. It was like real prevalent. I can remember an engagement where it was like the first 5 minutes of the engagement. I just went to browse to the website, registered for an account, intercepted my request. It had like stuff like you would expect. I'm registering with my email. I'm giving it a password, some name and all that stuff. What I guessed was, now sometimes it's role, sometimes it's admin, it's whatever attributes associated in this table, whatever the column value is. In this case, it's admin. I just put in like admin equals true or admin equals 1. And that gets converted when it creates that record. it says, okay, here's all this, this user with all this new information with ID, email, and also, by the way, hey, they're an admin, right? That's what that does. So you have to have some protection. Now, frameworks and libraries after it was discovered in a few node libraries, these types of vulnerabilities, now they have protections for this. But at the time, there was no protections other than just like plucking out of the request body the actual attributes that were okay, or saying only these attributes, like allow listing only specific attributes at the creation or update of a record. But nothing was, I guess what I'm saying is nothing was built in. So you would literally have to like manually parse the request body and extrapolate the parameters you expected and omit the ones you don't expect, like admin equals true. And that was your protection. It was just terrible. And like, luckily it's getting better, except for then, like, truthfully, the same stuff keeps popping back up. It's like it gets fine for a while as frameworks mature, and then a new thing comes out or a new library, and then boom, it's all over again in some new version. So let me actually, if you want to share your slides again there, Seth.
Yep.
Yeah.
Yeah.
So like, there's like an article we can post on that that was the result of some research around looking into this for Mongoose, because Mongoose had nothing in it to protect against this. And it was like, because it was a, no SQL injection, I think, type deal, no one really thought much. I guess it just was one of those things where, like, it's like, okay, well, in relational databases like MySQL and Postgres and all that, like, we've got that covered. We're used to it. We've got some libraries that are, have already secured against this. And then, with like no SQL, there's also no SQL injection. There's also mass assignment in a different form. So in Rails 2, 3, 4, 5, 6, I mean, I think we're up to 6 now. Basically in Rails 2.3, it would look like, or the reason I'm putting this in is the protections exist at different places, right? So earlier versions of Rails 2 and 3, the protections were at the model layer. You'd actually have you'll see on the left side where it says define, create, the left screenshot there. There's no additional, there's no sanitization and saying like, oh, let's pull out these keys, they're not good, and let's allow these other keys, or rather these other parameters. Nope, just says like params user, which is a big hash of whatever you want to put in there. Now, what it's relying upon, because this is in the controller level, is in the model level, to actually have those explicit attributes that are allowed to be mass assigned, meaning, throw in a bunch of data as you create a new user model object record. You had to define that at the model layer, allow the attributes, explicitly say it, and that's how you did it. Now, later in Rails 4 and above, what they decided was, hey, we don't want to be so restrictive and do it at the model layer. We actually want to allow for, again, more flexibility. And let me just say, anytime, this is probably more an opinionated thing based on experience, but like, the more flexibility, usually the more problems. So that is what it is. What it is. It's just the more options for things to go wrong. But anyways, so in the later versions of Rails, specifically inside of the controllers, is where you could actually say, like, here are the parameters that I want to permit. However, and that was supposed to be secure. However, again, to allow more flexibility, they allowed this .permit bang. And that means, instead of saying .permit and then here's a list of the attributes to permit for these parameters, instead, don't worry about it. We're just gonna like allow everything. Don't even sweat it. It's all good. And these are the types of functions that shoot people in the foot. So when you're doing, and again, like in your checklist, you're going through your authorization checklist and you see mass assignment. What I would encourage you to do is look at how the framework or the SQL library or whatever library that accesses your data store protects against that, and make sure that it's actually implemented. And you ever come across a case like this where there's like, okay, well, you have to like allow certain parameters at the like controller level, just make sure there's no bypasses is sort of the moral of the story there. Okay, cool. I keep hitting click forward, Seth, and it's because I don't have
Control.
remote control. Yeah, as I'm talking, I'm so confused. I'm like trying to hit. Yeah. Anyways, all right, cool.
So a few more checklist items here, right? Is it possible to bypass the authorization restrictions? So think of the :action that we talked about previously. Can a user escalate privileges through cookie modification or altering like the JWT or the session object or the session token, right? Or even fuzzing those URL-based parameters. And are there, references in the source code to the insecure direct object reference? This is where I started to talk about the patterns previously. And then are authentication and authorization flows the first logic executed for each request? Because if they're not, there are, it exposes portions of the application. And then how granular are the authorization checks? Is it just page? Is it controller level? Is it directory level? Is it all the way down to the function? Or is it just like per application? All this comes into play. Denied by default. Yes. I know there's a whole bunch of items in here. You'll probably want to look through these. Again, as you're implementing it per application, some of this may make sense. Some of it may not. Yeah, can you, circumvent things by using by attaching debug to the URL? Go ahead, Ken. Sorry.
No, I was gonna say, like, for the reasserting credentials, that's incredibly important. That's why we always talk about this one, because like if for instance you need to do something that's high risk, like for instance, if you've ever used GitHub, if you want to delete a repository, transfer ownership, delete an organization, do something potentially destructive, there's what you don't know is behind the scenes, there's what we call a high risk pseudo filter. And that means that you have to re-enter credentials after a certain period of time. And unless you re-enter those credentials, we do not allow you to go and make those destructive changes, right? And that's important. Like if you have a security impacting feature, like, hey, I'm going to add my SSH key and that's going to give me access to something, that should have a high risk filter. We talk about rate limiting as an authorization function, but certainly like re-entering and reauthorizing after a certain period of time for critically sensitive functionality is also an expected authorization check that you should be looking for.
Yep. Yeah. And I'm trying to think if there's really anything else. I think we want to jump to, Genghis Khan. So instead of talking about the checklist, let's actually jump into it. Now we are finally to the last info gathering of the day. So one more time, this time we're going to look at Skia Django. So it's another framework, it's another application. There may be a little bit more information there. Obviously it's Django and Python. We'll give you that for the tech stack. But you've still got to figure out what the database is, what the business purpose is, what risks exist for Skia Django. We got to map out the routes and get through the auth-z functions before we build our authorization checklist. So we're going to need to give you a little bit more time to get through this, at least to do a couple of checklist items for authorization functions or for the authorization controls that exist. Since you are going to have to step through all of the initial items. This will be the last time that we step through those initial info gathering phases today. So this is the last application that we'll pick up for today. So how much time do you think, Ken?
30 minutes at a minimum for this one. This is always one, but the good thing for everybody, and you mentioned this, but I'm not sure if everyone caught it, so I just want to reiterate. From this point forward, this is the last time you're having to do that first initial like text, like behavior profiling, tech stack, all that stuff. Going forward, every other exercise for the remainder of today and probably a little bit of tomorrow, we'll be building upon, it'll just be Skia Django. So until tomorrow when we get into virtual task manager, but that's something we do together. For you're good.
Yeah, yep. Okay, so let's dive into it. Let's take half an hour or we'll take 28 minutes on it. Yeah. You want to talk about CSRF protections a little bit before we do that, Ken, since Mike is asking?
Yeah, no. So I always like to look at the first, figure out what am I dealing with, what web server, what framework, and then I like to go into looking at the CSRF protection. So Seth's showing you what that looks like in Django, since we are dealing with Django. But that's typically I feel silly sometimes because I'm like telling people in a course, like part of our methodology is literally Googling things, and it sounds so silly, but it is truthful. Like you have to get or DuckDuckGo, whatever whatever search engine you want to use. But, using your search engine to reference documentation that these technology stacks give you to then ask like what CSRF protections they have. But that's not where it ends. The other thing to do is, once you realize what version you're dealing with, is I always like to then go look for research done in terms of vulnerabilities, like with that specific version, because sometimes people will tell you like, here's a nuance to be aware of, or here's a bug if you don't do this, and so like the protect from forgery we talked about with exception is clearly documented in people's research as like an edge case where things can go wrong. And so this is like, to answer that question, the two things you should do: look at the documentation, and then search for other people's research around like issues with that implementation.
Yeah. So as far as CSRF goes, right? Like realist, yeah. What Ken's saying, like I end up Googling things, and as much fun as I make of Stack Overflow, I read a ton of Stack Overflow posts because it's interesting to see how people have solved problems. And sometimes they do it securely, sometimes they do it insecurely. So, looking up CSRF and seeing what people recommend on, some of those developer forums is pretty interesting outside of using the documentation as well.
If you like Stack Overflow, there's a product for you, Seth.
So Copilot.
Yes, it's Copilot. If anybody doesn't know, Seth's been giving me garbage about Copilot. That thing that's come out, it's gotten a little flack. So yeah, just keep getting messed with by Seth on this one.
Yep. Yeah, so let's take half an hour to do this. And if you've got questions, jump on in. I know we need to break anyway, so you probably want to step away. So let's do 35 minutes. We'll start right back up at the hour. Should we do, so that would be 4 o'clock Pacific?
That sounds right.
Yep.
Math wise,
yeah. Okay, so let's start at 4 o'clock Pacific. Ken and I will be available, so feel free to DM us directly on Slack if you've got a question, or ask in Zoom chat, wherever else, as you step into Skia Django and as you start to play with the authorization stuff that's involved there. But otherwise, go forth and start by making a copy of example template, and then start, go for it. All right. Let us know if you've got questions.
About to get started again. Just let everyone know. Trying to gently reintroduce the sound of our voices.
We know you've missed us for the last, 20 minutes or so. All right. So Skia Django. Let's start with tech stack, business purpose. I want to hear some risks too, based on the tech stack and the business purpose. Okay, yep, it's a to-do list app. Sweet. Python, Django, SQLite 3. The backend is fairly easy. Seems pretty straightforward. Yep, they can change their account so they can, make updates to whatever is in their account, right? At some level, at least change their password. I see that one in there. What about risks though? We haven't spent a lot of time talking about risks in the applications up to this point. So if it's a to-do application, what sort of risks are we concerned about? If this is, I don't know, a large corporation is exposing this for some reason. Yeah, Ilya, you're probably right. Accessing other to-dos. That's one thing. So that's an authorization attack, right? That we're gonna want to figure out what the endpoints look like that allow access to to-dos, and then we can trace that through. That's probably the biggest thing. The users escalating their privileges to see anonymous users seeing to-dos, or users accessing someone else's to-dos. So insecure direct object reference, access control, missing function level access control. Yeah, deletion of to-dos, right? If we can delete someone else's, it's obviously a problem. So those are all awesome risks that feed right into our authorization checklist. Did anyone happen to look at any of that there, or did we just look at the authorization functions? And Ken and I realized that some of these are contrived because they are, obviously they're purpose-built applications, but we can dive a little bit into Behemoth if we have time on these as well. Okay. So let me see. Let's flip here. Okay. So first things first, authorization functions. Looking into views.py, you see index defined, right? Sweet, you've got your typical index page, whatever. It doesn't look like there's anything there. We do have login required, right? So we've got that authorization decorator. We know that's an authorization function. Where does that come from? There we go. Okay, so it comes from Django. There's the contrib auth decorators. So it's part of this Django contrib auth package. Yeah, and Dylan, awesome. There's additional settings, additional items and settings.py, probably for Django contrib auth. Whoops, that's the wrong one. There, maybe it wasn't. Yeah, there we go. Settings.py. Yep. So we see some sessions middleware, right? For Django, settings.py is a treasure trove of information. This secret key, if I don't know what this is, we know it's hard coded here. that's probably an issue. We're going to want to note that down because that may be useful in the future. But what else do we have? Debug is equal to true. Yep. And we're going to get into some of the configuration stuff. And then equals star star. Yeah. Let's see, auth password validators. These will get into authentication. Those will be interesting. And depending on how you're doing an assessment, you may or may not build all the checklists out first. But where's the Django contrib auth? There's a login redirect, the login URL, the auth user model, right? So if we want to look and see if there is some sort of mass assignment, that's where we want to look, is in that models.py. All right, so let's see what else is there. urls.py. Okay, that's admin. That's not the intro, right? Or that's not the to-do list. Those were in intro. See what the urls.py looks like here. Okay, yep, Django contrib auth. We're importing views as auth views. So apparently we've got some to-dos in there. Or there's the password and the sign up. Okay, this is all becoming, I mean, we're figuring out where that's actually coming from. But what are the, we've identified that login required is there, right? That is the authorization function. But if we want to check for the authorization between, or the access control between users, it's not, it doesn't exist on that authorized or that authorization function level. It goes deeper than that. Let's see if I got here. What do we have here? Okay. Yep. So if we're looking at to do, you'll see that there's this. There is an objects.get. The primary key has to be to-do.id. Underbar ID is that's passed in, and the owner has to be the request.user. So that's not something that's user controllable. The request is the request object, and it's filled out by Django contrib auth. So in this case, it doesn't look like it's vulnerable to a traditional insecure direct object reference vulnerability, right?
Tomorrow, when we get into the VTM, which is a virtual task manager application, it's like a fully fledged version of this Django. And it has more comprehensive and robust login decorators. So even though in this one, we're just trying to get you to go through the exercise and figure out the decorators and look at the documentation, tomorrow is going to be a little bit more intense in that regard, but yep, we'll be doing it together.
Yeah. But if we take a look, right? So in this, I didn't have in the slides. What do you notice? So we've got the, on line 21 there, the objects get owner equals request.user. If you notice in the post, when we do the get lookup, what is it that we're forgetting? Right here on line 34. Anyone? Yeah, Michael, exactly. We're missing the owner. So if I was building a semgrep check for authorization for this application, I would be looking for an objects.get that has two, or that has show me all of them that only have one parameter and not two parameters, right? Because that means the lookup is happening here, but it's actually not doing a validation. And it may be that that's a little bit of a misnomer and I may get a lot back. But in this case, that is vulnerable to insecure direct object reference in the post request where it wasn't in the GET request. Now, it doesn't mean that I'm going to be able to see somebody else's to-do item, but I could override it, which is a problem, right? So I could, this is a denial of service issue, or there's some other, I mean, basically it's a problem because we can overwrite, we can take data apart, right? Create to do. This looks fairly, it's pretty innocuous, but we could step through each of the login required and actually see what is there. So this is getting all of them, to-dos completed. See, most of them look like they are getting some sort of a request user in there. But for some reason, we forgot to do it on the post request that is vulnerable to insecure direct object reference. This is something that we're going to have to note, and we'll throw it into a list, into our findings list under, hey, guess what? It either needs to be checked or it needs to be validated, but it does look like it's an issue. Okay, cool. All right, anything else there on authorization before we jump into authentication? Or any other questions, right? I know we're stepping through these, but we do want to get through a few of them before the end of the day today, and we've only got a couple hours left. So
I don't even think we've got that. I think we've got 50 minutes.
Oh, really?
I think that's the case.
All right, cool. All right, so authentication. Then we're just going to keep going. We'll barrel ahead. You'll get more familiar with these the more that we do them, right? As far as like authentication, authorization. So especially as we step through tomorrow, we'll pull out like mass assignment. I mean, if we were looking at Skia Django for mass assignment, I would be jumping back into models.py, like I said, for to-do users, right? Now it looks like it's just an abstract user. It's based on the abstract user auth model. So there may be an opportunity here to do mass assignment, because depending on what this abstract user is from Django contrib auth. Oh, cool. Yeah, Mike, you're right. If we're going to 6 p.m. Pacific, we're got an hour 50. Okay.
Okay.
So yeah, we're good. And this is going to require a little bit more in-depth analysis because I don't have access to abstract user outside of the Django documentation, right? Let me see if I can find that really quick. Yeah, because it looks like it does have user is staff, is active, is super user. There's definitely Booleans that are associated with this that could have mass assignment style effects. And we're not restricting it here from abstract user. Okay, Diane, go ahead.
It's okay.
Yeah, all this was going to be in the documentation as it is, and you can ask questions tomorrow. We'll step through a lot of it. Ken, what were you going to say?
Same thing.
Okay. All right, so let me show you where I'm looking, right? So I did a Google search for Django contrib auth, and it took me to this page, right? And the first thing that lists out here is this models.user, which is the one that we're actually subclassing for to-do user. And you'll notice it contains things like is staff, is super user, right? So if I run this application, this would be an interesting test to see if it allows me to assign is super user to my creation, because I'm pretty sure we're just passing that all directly in. If we look at sign up under use.py, I don't even think there is a sign up in here because it's all, oh yeah, it is. Yeah, to-do's creation form. So if we look at that one, it's just a subclass of user creation. Okay, good. What do we notice here? So I'm running through a checklist right now. I know we didn't document it. I didn't show you my notes on it, but I'm running through a mass assignment checklist to see if mass assignment is possible. But what you'll notice on this user creation form is it has limited fields. It's only accepting username, first name, last name, email. Now, the one question that I have is whether or not that's going to limit what's accepted when it's doing form validation, and whether or not that's going to allow for is super user or is staff to be appended when we create the new user, when we update that form, when we create it new. So let me see here, like we're going to spin back. And I know I'm doing this all on GitHub. If you guys are in Atom or Visual Studio VS Code, you can jump through between these fairly easily as well. That's the login required. Well, and that's where I have questions is URLs, sign up as view. Yep, so it's just going straight to that create view. So I'm probably going to start looking into Django, contrib, auth, mass assignment, and see what other people have figured out here, right? Customizing. And sometimes I mean, honestly, what you're seeing here is what we go through. Like I said, Stack Overflow, right? Yeah. Group, you're getting that out. So that doesn't seem to be relevant. And the amount of time that we spend in search engines is actually pretty, you know, I don't know if it's disheartening or amazing or what. Yeah, I'm not seeing that there. User can authenticate. But sign up is going to be an issue. Validators, right? ASCII, group validators, permissions, anonymous user. Yeah, methods. I mean, this is my concern though, right? Is that is there and then we're accepting it by default. I would expect that to be out of it, but I'm not sure. Let's see, we got a screenshot shared by Dylan. What is it? Yep, validation errors and saving the object. Good find, right? Yeah, it updates the use object. Yeah, so I'm pretty sure that limits it to what is in there and it drops anything else. So even if we add additional parameters, it shouldn't be there. But what I can do is we don't need to jump down it too far. That's a question that I have. I'm going to make a note of it. And I'll actually do a test before we jump into things tomorrow and we can move from there. Okay, so that brings us to authentication. We did talk authorization, what people can do. We've done a couple of checks there, a simple, you know, insecure direct object reference, like some mass assignment. There may be some business logic flaws that we didn't step through, but at the very least, we understand what's going on with Skia Django, and now we can look a little bit more in depth at the authentication flaws that exist. Like we said, authentication establishes user identity. It's who a person is. They have to prove some way, and we traditionally do that through username and password. And the thing is, we have to realize that identity includes any process that identifies users. It's not just the authentication process. It's also sign up. It's also forgot password. It's also the trusting of token values. It's, you know, reset password flows. There's multiple flows that anonymous users access when interacting with the application to establish identity. It's not just the login process. Anywhere that we redirect users to the login page when we're done is probably a place where we need to be looking and thinking about authentication issues. So any application functionality that identifies users is included in this review. How does an application normally confirm identity? Yeah, I already mentioned this. I'm kind of barreling ahead. I should have asked instead. Right, Ken? Yeah. He's just going to smile. Okay. Confirm identity.
I'm actually looking at documentation for the Django models. That's why. Sorry.
That's okay. See, we all go down rabbit holes, and it's appropriate.
I was curious, actually. You had me curious on how that actually looks. So.
Yeah. the items that we'll be looking at here, right? The vulnerabilities that typically come out of this review: broken authentication, so anywhere that we can bypass a password or jump through those hoops in an unintended manner. User enumeration, if we can figure out what a user is, that's half of the information we need in order to take over an account. Session management issues, can I steal the token? Are we generating JWTs like we should be? That kind of information. Or can I get access to the secret key that's being used to create those tokens? That's an issue as well. Authentication bypasses, I think I just mentioned that. Brute force attacks, is it possible to brute force and just log in using passwords, or are they weak passwords, that sort of thing? Password stuffing, credential stuffing, that's all an issue when it comes to authentication.
Yeah, these days, like, sure, there's the basic hygiene of password length or complexity, how many times you can submit, what happens, depending on if someone's trying to perform an account takeover. There are all these things that are kind of, traditional web security. But these days, the things that you'll typically see in terms of more challenging aspects to this is like dealing with two-factor authentication. That's always a really, really tough one for sure. Password resets are always pretty difficult to deal with. Yeah, it's definitely one of those things that is contextual. Again, going back to understanding the application. For instance, if you look at GitHub, where I work, we don't care about username enumeration at all, not whatsoever. And there's a good reason. It's a social coding platform, essentially. So we want people to know each other's usernames. However, the story Seth typically tells about which I'll let him tell because it's so bad and hilarious. But you know what? I'll shut up and just not say anything because you're going to talk about it. But yeah, there are obviously other places where that is definitely username enumeration or email enumeration is a problem. But yeah, like I would say two-factor auth is a big one these days, or multi-factor auth.
Yeah.
Yeah.
Yep. And I mean, there's flaws that exist there, or SAML,
CAPTCHAs,
right? Yeah, like there's ways that we can mess up identifying users through those mechanisms, and there's stuff that we need to look for in the code to see if there are bypasses for a lot of that. Now, I've got.
By the way, if you see a custom CAPTCHA, assume it's vulnerable.
Yeah. Assume it's vulnerable. Yep. I don't know. ReCAPTCHA, as many cars as I've had to identify, or traffic lights at this point, I start to question whether or not I am an Android or some sort of a bot at this point. Yeah, okay, so spot the bug here. What is the problem, right? This is log in to Task Manager, but what's the issue that we have? Yeah, Ilya, good spot. The top one specifies what actually failed as opposed to just an abstract message. So that simple difference allows us to enumerate the username, right? So the bottom one tells me, hey, I used a valid username even though the password was bad, whereas the top one says, oh, that was invalid. I didn't find the username in the database, so it doesn't exist. And like I said, user enumeration, a user account ID is usually half the information that we need to log into an application. The password's the other portion, but with credential stuffing, all the leaks that are out there nowadays, getting lists of passwords to use against valid usernames is not that difficult of a case. Now, Ken speaks to a user enumeration. I've been dealing with this my entire career. My first security job was working as for penetration testing at a bank, as they were onboarding all of their customers to online banking, right? They'd finally come up with a web application for online banking. They were pushing all of their customers into it. And they decided, hey, during the user enrollment phase, let's just use the one piece of information that we have that's unique for every user and allow them to put that in to enroll in online banking. Now we're in the States. what piece of information do you think the bank chose to use that they knew was unique per customer? There we go. Yes, you all got it. Social security number. Now, okay, social security numbers, obviously, right? Like how many digits is that? What, 9 digits, right? That's pretty easy to figure out. The other problem was I was working for a regional bank. So the bank itself only existed in 2 or 3 states. Back then, this is no longer the case, but back then, all social security numbers were issued based on the state that you were born in. All you have to do is go look up on the Social Security website, hey, what numbers were issued for the period between 1970 and 1990 in Utah? I'm based in Salt Lake City. What are the prefixes associated with that? And they went and they gave me a list of 50 different prefixes that they had used over the course of that time. I dropped that into a bot that went to this page, basically did a request and said, did it redirect to the local page or did it go to the next one for the enrollment? And we was able to enumerate something like 100 to 150,000 different valid social security numbers for bank customers. All within, it took me probably 30 minutes to run this script and put it together. And that obviously that's a bad thing, right? It's bad because this was the way that they had decided to identify users. The only piece of information that they required was that social security number before it stepped through. Now, it didn't mean that I had the name that was associated with that social security number, but at the very least, it was putting me on the right path of identity theft is basically what it boils down to. So the issue that I have with user enumeration, again, this goes back to like the hygiene and you're right, identity theft is not a joke. Is that I still find user enumeration in it's probably 60 to 70% of the applications that we test. It's a hard problem to solve. Now, it's usually not as easy as this one is, or the social security number example that I gave. Those guys fixed it in fairly short order. I mean, just pairing it with social security number and like a birth date did away with a lot of it, right? Because it takes, and then some, brute force protections on top of that. But I still see it across the board. It's usually in things like the password reset flow, the sign up flow, forgot password, right? Like it's not always in the login flow anymore, but I still see it quite often. And so you've got to be careful, and you've got to be able to identify that from the code itself. And I've gone off on user enumeration, Ken, and I'm not sure where we're going to go next. So anyway, so user enumeration, right? This one's interesting. Do you want to talk to this one?
Yeah, this is not so much an issue anymore, but why we always show this one is for language. So we've talked a lot about framework nuances, and you probably have noticed we haven't talked a lot about language nuances. And this vulnerability actually points to language nuance. Now, I want to be clear. This is exactly the vulnerability we identified. However, we had to condense the code so that you could read it all on one slide. So this wasn't all in one place. It was like, call this method, which is defined somewhere else. But for our purposes, it's all in this one place. So what you see here is we take a username from the request that the user, sends some parameter that has a username, also sends a current password. And we do a DB lookup, taking the username value. So we basically say, hey, is the current password valid? And if it's valid for that user, then there's a match. And if there's a match on line 31, we do that check, if there's a match. And line 33, we take the password parameters supplied by the user, and we set that as the new password. Now, in and of itself, this all kind of makes sense. I mean, obviously I wouldn't default is match to true. I would default that to false, typically, but either way, this is pretty standard, right? Now, what had happened was we had this weird situation when testing the function where there was this like almost race condition situation where sometimes the password was updated and sometimes it wasn't. So Node.js is now a little bit more thread safe, and they use different annotations like async and await and things like that to protect against this specific vuln, but it was super common at the time. And again, as a language nuance. So what would happen is, and again, this is actually like pretty much exactly what we looked at, just all condensed into one slide. There was a variable, it defaulted to true. I don't think it was set as true. I think it was something to do with like, I don't know. I don't remember the specifics, but whatever happened, that value did actually default to being, I think it was more of like not a true check, but just like, does it exist? Right. And it did exist because of the way the variable was instantiated. And I'm talking again about on line 25 is match. So just assume that it passed the conditional check if it didn't get reset to false during that lookup on 27 through 30. So what would happen is in Node, the execution's not line by line. In most other languages, you look at it and it's like line by line execution. Line 26 has to execute before 27, before 28. Node does not do that. You have to specifically say, and back then we used callbacks to actually do that. Now it's, like I said, a different annotation. It's like async and await and all that. But at the time, if you didn't have that callback function returned and then like inside of a function, inside of a lookup, like you see db.user.find, if that's not inside of a function that gets past a callback value, and then you wait for that callback value to have been created and then do the conditional lookup, it would just execute whatever lines it felt like executing at any given time. So of course, because on line 31 is match just was always like instantiated and true for all intents and purposes. If for some reason that those lines 27, 30, well, not for some reason, if they're just like the code executed lines 25, skipped through 27, 30 and executed 31, which happened. That's why we caught it, the race condition. It would just set the password to whatever you wanted. You didn't have to give it a valid current password because that lookup never really occurred. So we leave this in as for two reasons. One, I think it exemplifies weird authentication bugs that we've seen, but also really exemplifies the fact that if you're getting into a language you're not super familiar with, your best bet is to spend a day getting up to speed on like the weird things that potentially can happen. Obviously, you should want to have more than a day and more of a heads up than a day. But my point is if someone just all of a sudden dropped something in your lap and you had to do it, you should invest some time learning a little bit about those edge cases in the language.
Yep. Oops. Okay. Good. Anything else on that? Yeah. So it's the asynchronous nature of Node, basically, is where we're going with that. Other checklist items. Well, okay, so checklist items, not other ones, right? So identify the authentication flows. Figure out how users are identified, like what pieces of information they have to provide. How is authentication handled on each endpoint? Is it, the credentials being provided, or is it just the cookie value that's authenticating people as it goes through a filter? Are there any hard-coded accounts? What are the hard-coded values that exist?
Oh my gosh. This one, if we could pause, this has annoyed me to no end because this happens more often than you'd realize. Like, where people will say, oh, if the email ends in our company email, boom, you're good. Like, have this role you don't deserve. Or one time I used to work at Living Social. And if you're not familiar with Living Social, it was a competitor to Groupon in 2010, 2011, I think it was. Anyways, some developer was debugging some functionality and they actually put in like our CTO's like username as the lookup, hard coded it in, and accidentally pushed that to production. And like everybody who logged in was our CTO. So this happens all the time. But the most annoying one is definitely when people are like, oh, if it ends with this, then allow that role to I mean, it's yeah. Anyway, sorry. It's just pet peeve of mine. I see it.
Yeah. Yep. Auto assigning permissions based on an email address. And we use email address for account logins all the time nowadays. So it's like part of me understands, but it's also just a shortcut that we've got to be aware of. Does the app allow for easily guessed default or common passwords, right? Like what are there any password restrictions in the code base itself? A lot of times there's not. We find this, yeah, like I said, all the time, like these authentication issues. How are usernames determined? What are the naming conventions? Does it allow for easy enumeration, right? Is it just first name dot last name? Does the user even care, or does the developer even care about user enumeration? Because we could drop all of those checklists if we don't need to. If they don't, that's what I'm saying. Server responses, information disclosure. Modern hashing algorithms. Are they using MD5? Are they using crypt? Some old password hashing algorithm. Obviously, that's an issue. Let's see, security policies and security frameworks. What are the standard security frameworks? Is there code specific to the application? Nowadays, most modern applications are going to use something like Django contrib auth to handle user authentication. We don't write as many password checking routines as we did 10 years ago. We just don't. And that's mainly because we're offloading that security risk and that functionality development, the development of that functionality to third parties. That's not necessarily a bad thing, but depending on how it's implemented, it could be. It's usually a red flag to me if they're trying to implement it all on their own, especially some of the password hashing that I've seen over the years.
Similarly, it's also a red flag when you go and you look at, and this is true not just for authentication libraries, but this is true for any security impacting library, whatever it might be doing, is when you see, and I know this is common sense, but it's something I like to do is go and look at like, how many stars does that, how, I can't say stars because it doesn't exist on every platform, but what I mean is how frequently is it updated, how many people are contributing, and how many people are using it, how many eyes are on it. And then I also, again, like to go and look if it's something I've never seen before. I like to look at the research that's been put out regarding it, if there is research. And if there isn't research and there aren't a lot of people using it, and it's a relatively new, especially with cryptographic / authentication related libraries, if it's relatively new, not heavily vetted, not heavily used, I'll kick that right back and be like, nope, that's a smell to me. We need to find another library that meets what your needs.
Yep. Yeah. And then, as I'm looking over the rest of this list here, right, like how are user management events handled, right? The authentication failures, like, again, it's anything to do with identity, right? Are there flaws in that process? Does account lockout give user enumeration details, right? If somebody tries to log in 4 times and after the 3rd time they get an account locked out message, yeah, it just made it a little bit more complex for an attacker to enumerate users. But now they have to send 4 requests instead of sending 1 to enumerate all those issues. Hey, that's fine. Yeah, are suspicious event handling, are those handled properly, or suspicious events such as failed login attempt, session replay, attempted access, restricted access. Like, what happens when someone tries to access data that they shouldn't be able to? Are they kicked out immediately? Are they just given an error message? Like, how is that handled? Depending on the sensitivity of the application, it may or may not be something that needs to be strict. We talked about password policies already. Cache control settings, right? Like, can somebody get at data on a a system that's been compromised, right? So if I compromise somebody's browser, can I see data that's stored in the cache there? That could be an authentication issue. And encryption mechanisms, right? Are they actually using HTTPS? Is everybody familiar with the wall of sheep, right? We're at Black Hat, but DEF CON wall of sheep. About how they post, not really. Okay, so Mike, the wall of sheep started as basically it was just a projector and a screen and a list of accounts of people that used the conference Wi-Fi at DEF CON to access insecure services, right? So they would telnet into their business, or they would use IMAP and not IMAP, secure IMAP, to get their email. And so their credentials would flow over the wireless network insecurely. And so DEF CON would shame them. The wall of sheep, they would just pop up username, password, service, right? On a screen, and anybody that was walking by could pick those credentials out of the air, right? Yep, it's a little brutal, but it's still there. You can still go see the wall of sheep in the packet hacking village, and you still will see some of those creds. It's a lot more protected nowadays. Not as much of it happens, but a few years ago we started to see things like Google session tokens show up there, because Google didn't want to pay for encryption of all Gmail traffic. So they'd have you log in using an HTTPS or a secure page, but then they would redirect you to use Gmail, but just with a cookie value that was authenticating you over an insecure or over plain text channels over HTTP. So that happens. So you'll still see that. It's a pretty interesting thing to watch during DEF CON, to see who the noobs are, right? Like the people that show up and use the conference Wi-Fi and trust that, it's going to be protected even though it's not, right? I think we all know that at this point. Manual approval, access granted automatically. Can we script that up? Validation emails, like anytime a validation email token is sent, right? Like, how are those actually generated? Is there some sort of insecure direct object reference there? What can happen? Mass assignment, and then, files and objects owned by a user removed, archived. Go ahead, Ken.
I want to touch on two things. One is the token generation. What I'll do is, if I can run the code locally, Seth's actually seen me do this. I'll mock up whatever code they're using. I'll run it. I'll generate, say, 1 million, 2 million, 3 million tokens. I'll run them through burp sequencer just to get an immediate tell if things are, the entropy is not quite right. So what I mean by that is I'll run the function, generate output to a file. It'll have 3 million tokens. I upload it into burp sequencer. Let it tell me what the entropy looks like. If there's something if it's not looking so good, I need to start digging into why after 3 million tokens it's starting to look a little dicey. The second thing, it sounds probably weird, why would it matter if file and objects owned by a user are removed or archived, right? So it's important that when a user, because authentication is authentication, so user creation is the first part, but user destruction is another, right? When you want to delete your account. Now, if you delete an account, there should be appropriate associations and directives such that if you delete your account, it deletes all of the data that was stored in the application, unless there's a specific reason not to do that. And the reason I say that is, and once again, this bug bit me. 4 weeks ago or 3 weeks ago, this happened again where, and it doesn't, I'm saying again in my career, over the span of a long time at many places, this has happened where the user account gets destroyed. There's again, some issue with auto incrementing or the migration of identifiers not properly incrementing. Somebody registers, the system's go look up user with 1234's ID and give them all their content. And boom, all that stuff that didn't get deleted that was associated with previous user 1234, or sometimes it's based off username. And which is another flaw also, if it's purely by a username, which is a controllable value that can be changed by a user. It's just that data gets associated with somebody it shouldn't be associated with. So it's actually it's important is what I'm trying to say. Because it happens and it's so annoying.
It happens and it's so annoying. Okay, yeah, so we've got a couple of different authentication review checklists. Like there's the overarching, there's the registration we just talked through. This is the sessions one. What Ken was talking to as far as generating the sessions to see if they actually are using industry standard, encryption or randomness, or if it's something that's local or custom to them. Our authentication token set with time limits, right? Is everyone still using Facebook session tokens that never expire, right? That's kind of the standard, especially for social media or social websites, that those tokens don't ever expire. So if you can get a hold of one, it's a problem. Security parameters. Some of this will flow into the configuration checks that we do later on as well, but we still want to look at session IDs and how they're protected here. Sent over a secure channel. Are they invalidated? Are CSRF tokens set? Are CSRF tokens actually unique for all authentication requests? Like, how is that actually happening?
And if you're not familiar with session fixation vulnerabilities, or you maybe everyone's familiar with them, but that's why we invalidate a session before a new login is made, so that you can't visit the site, get a cookie set, log in, cookie stays the same. So now your identity, or well, if you're tricking somebody else to do this, someone else would be logging in with a cookie value that you knew because you visited the site. And then if they logged in with that value and the cookie never changed and the cookie value and now it's associated with their ID, you can like request the site with that cookie, known cookie value, and that's session fixation. So that's why we make sure it's invalidated before proceeding forward. It's a absolute standard that should be always done.
Yep. Cool. So what's the vulnerability here? Token leak in header. I mean, you're right. It's going to be in that, homepage # token equals. Yep. There's a second one there too, Sam. If you can see, yeah. It's my favorite one. Yeah, there we go, Michael. Got it. Mike's got it. It's the user enumeration is there as well. Anytime that we're just returning that information, user not found, as opposed to incorrect password, it's not great. So
technically there might be a third vuln but we don't have all the code, so who knows. But
Ken loves JWTs, so yes. Go ahead.
Yeah, I love beating up on JWTs. Yeah, there was like, I don't know if everyone or anyone on the call at all had seen this, but like, gosh, you know what? I'm not even going to quote a time now because I don't know it could have been the last 2 years at this point. I don't know. It's all been a blur. But there was, I thought pretty recently, maybe in the last year, where it was found that like with a lot of these JWT creation libraries, if you don't pass in explicitly the algorithm that you would like to have your JWT signed with, it would just default to nothing.
Yeah.
So there's no encryption used. So apparently a bunch of libraries are vulnerable to this. I don't know, just more funny, worth noting.
Yep. Default to open, right? Yeah. Default to, yeah.
Yes.
This one's a little bit harder to figure out. No, it's not. This is the same one that we looked at previously. So failed login versus invalid username. We've already seen user enumeration. I won't keep beating that horse at this point. Okay, so we want to build an authentication checklist for Skia Django. Based on what we know about the to-do list application, let's review what the authentication looks like. And then we want to do it for Bahema as well. So we're gonna build kind of 2 checklists out. What I would like you to do is think about the risks associated with Skia Django first, come up with at least 3 authentication checklist items based on what we've talked about, just barely, right? And then we're going to do the same thing for Behemoth. Behemoth is a larger code base. There's more endpoints. There's more authentication mechanisms that we probably have to be concerned about. But let's build out that authentication checklist, at least 3 items, if not 5 for each of these, and then spin through and see what you can find. We'll have a couple of you talk through it as far as what you identified, what the risks were that you were looking at, and whether or not there were issues. So let's do that first. Skia Django. So take, probably 5 to 10 minutes to do Skia Django, and then 5 to 10 minutes to do Hema. Ken, how much time should we do that? Should we do 15, 20 minutes on this one?
Yeah, I was just looking at how many slides we've got. We are at the authentication stamp or authentication point with an hour and 10. Honestly, I would say 10 to 15 minutes at the most. I guess if you've got Behemoth in there, 15 minutes at the most.
Okay, yeah, let's do 15 then. So we'll come back 5 after the hour, build out those 3 to 5, and then we'll talk about it when we get back. Yeah, we do have a few sections that we want to still finish up today, right, Ken?
Yeah, I mean, we want to get through at least our next section is auditing, Seth's favorite. We've got injection. That's most people's favorite because it's, injection is always a fun one. Yeah. And then, I don't know, but if we can push the envelope, I doubt we get there, but there's also cryptographic analysis. Most typically what we find is that, we might get through injection and we'll just do cryptographic analysis. But anyways, I'll be quiet and let's get started.
Okay, 15 minutes. Let us know if you have questions, and then we'll have a couple of you speak to it when we get back.
And I am going to go get some coffee.
Same. Okay, and we're back with our fifth exercise to walk through today. Skia Django authentication checklists, right? Where are we at? Based on the threat profile that we have, or the risk profile that we have of this to-do list application, what are the authentication items that we want to look into? Someone willing to share what they came up with? Okay, Michael, check the owner of the to-do items, right? Perfect. Anything else? We lose everyone else. Let's see.
Looked like most of the authentication was handled by the Django packages.
Yeah.
I was kind of need to look at the out-of-the-box setup since it doesn't look like there's a lot of configs included in this for most of them.
Yep. Yeah. So it's realistically just, hey, what's actually implemented? It doesn't take a lot to check it. If I was reviewing it, I'd spend more time in the documentation, figuring out, okay, how is something actually being implemented, as opposed to the code itself, because I'd be looking in settings.py, right, to actually see what the authentication mechanisms were. The one concern that I do have right off the bat, let's see if I go into Skia Django here, settings.py, that secret key, because I know that's used to actually generate the session values. The fact that it's hard coded gives me a little bit of heartburn, right? That would be an item that I would be noting. It's probably not a high severity item, but I would be noting that because it exists there. But otherwise, like the authentication issues that are going on, right? These auth password validators, I'm going to be checking to see if I could put common passwords in there. It looks like it does common password validator. So technically password 1, 2, 3, right? Those common passwords shouldn't be allowed. But it also doesn't do a lot of custom attributes here, right? So this minimum length validator, it defaults to 8 characters, which is okay. It's not great, but it's okay. And there isn't necessarily a complexity restriction in here. I'd probably be noting that from an authentication perspective. But otherwise, those would be the initial items that I would look at there for authentication. I mean, Ken, what else do you have on your list? Or is there somebody else? Oh, check failure messages to discourage enumeration. Yeah, great, Mike. Delete stored password or keys. That's really specific to the to-do stuff. Yeah. Ken, anything else that's on your list there for Skia Django? No. Again, Skia Django's like purpose built. I think there's going to be more interesting things in Behemoth. Did anyone come up with, or what did people come up with for authentication checks for Behemoth? This is a much more complex application, obviously. A lot of the same things, Mike, that you mentioned for Skia Django would apply for Behemoth as well, right? Maybe not the owner of to-do items, but some of the others. Right? Yeah, failure messages, like how does it actually fail? My concern here is the different roles that exist. And I know we didn't do an authorization checklist for Behemoth, right? We just didn't have time for that in the previous exercise. But that would be an interesting, I know there's an admin role, right? There's this admin role, controllers that we want to take a look at. But it also looks like there's a patient's role. There's an employee role. So that identification of those different roles becomes interesting. And then also the I mean, it's mass assignment between those. Yeah, finance, inventory, payroll. How are we identifying users through any of that? That becomes a serious issue. And let me see, like, I think if we look at config, like there's interceptors that are in here. This may actually have some of the authentication, or it could not, right? Wow, it looks like these are SQL query responses, interceptors. That's not going to help us much, but that is interesting as well. Express. Oh, that's right. You are already in this one, Ken. That's got helmet, the Redis store. This is the session. Okay, so that session secret. HTTP only is true. It doesn't have, oh, session secure cookie is true, right? So these are some of the items that we talked about as far as session protection that should have been on our list. We didn't actually get it noted in there, but it should be on our list to actually see. As long as it's in production, we should actually be good there.
What's that?
Yeah.
Sorry, I got distracted. Lines 85 and through 87. What is it? Is it just like taking every message? And I'd never noticed this before. Like, what is it doing? Anyways, sorry. I'm like, why would it be doing that?
It looks like a logger, right? Like that's what Morgan is apparently, but we haven't gotten to logging yet, Ken. Slow down.
Sorry. I know. I'm just like, what? I've never noticed that before. It's weird.
Yeah. Okay. Yep. Unauthorized. You're not logged into the system. Request session user. So that's got to happen before we get to Express. Okay. So now we got to go all the way back to server and app.js. Maybe config, cache form. Wow. We got so much going on here. All right, we're not going to go too much. Anything else that people called out on? Like, we probably just want to do a search for passwords. I should probably flip over to Adam instead for Behemoth, and we could actually search through. 1 second, let me do this. Slack. Right, okay. So that's not one, that's forms.py, that's not it, right? But we can do a search in Behemoth for, let's just look for a login, right? Okay, looks like there's a auth.json, right? That looks like it's just translation though, but that could be interesting. Users.json, source app.js. His login state is authenticated. Okay. So it was in a slightly different spot. I was looking on the server side. It looks like there's a client side that we need to be concerned about instead, right? To actually figure out where the login happens. So let's see, redirect to login if not signed in. Okay, that's great. This is exactly where we want to be. Startup config. And it looks like it's pulling there from, one of these is actually going to login. Target login. It's not authenticated. I think that's in here somewhere. Login, password meter service. I remember we were looking at that. There's session.js. And I should already know this, right? There's service.login from my initial discussions and initial documentation on Behemoth. I should have identified the issues, the interesting functions and the interesting files for login, logout, and authorization. So there's authorized, check user authorization, right? This is where it starts to get interesting. Go login. See if we can find that state login. I keep missing it. This is my own fault here. Okay, now I'm just jumping around. Auth injector, There we go. Session.js. Session login install. And there's login.html. At the very least, we know that that's the controller. There we go. Login controller. Woohoo. Perfect. So this is what it actually gets passed to. And we're checking all sorts of items. Now you can see how we can jump down the rabbit hole pretty quickly here, but here's the login function, the form. If the form's invalid, drop it back, but otherwise return session login VM credentials. So it hands the credentials over to the session that we were just looking at, and then, you know, handling the login response based on what's going on there. Max attempts, too many tries, right? So it looks like we've got an issue with authentication like user enumeration, that when someone tries too many times, whatever that max attempts is set to could actually result in, you know, user enumeration. Let's see if I can find. No, it's not in there, but max attempts is being imported in there somewhere. Let me see. Okay, so that, like, anything else that people would look at in Behema, right? Like, I know it's a lot to take in. Maybe that's one that we can look at as a group tomorrow. Yeah, you saw it at 3. You don't remember the file. Yeah, because there's so many that are in there. And that's just it. It becomes an exercise, and we've got to make these like, we've got to document things as we move along, because if we don't, we're going to lose it and we're going to end up spinning our wheels, like I'm doing right now, because I'm doing it live, and that's always fun. Mm-hmm. Oh, auth.js and server controllers, good call. That's probably a good place to look too. Oh, Lodash, yep. Login route, constant login username, request body, right there it's coming in. We're calling login from that. Looks like it's coming from one of these, probably the DB library, I would guess. That's doing some comparison there. Yeah, I'm trying to do a search on things when that doesn't actually have there, but
it's coming
anyway,
from login route, which is defined where that's got to be imported from one of these.
Yeah, I know.
Yeah. Oh no, sorry. It's oh my God, it is getting late. That's what the problem is. No. So, and just so you guys know, I'm on East Coast, so it's almost 9 o'clock where I'm at. So I'm getting a little, but yeah. So you see that. So that login should be. You're right. That login on 35 statement, because yeah, what am I talking about? Yeah. So 35 login, that should be coming from.
I would think it's coming out of.
That might be Lodash, right?
Is it Lodash?
Actually, let me look it up. I can tell you right now. Let me look through the code. This is not our primary. Let's see. Sorry, what file were you just in? Express.js?
It's under
awesome.
So Behema server controllers auth.js.
Right. Okay, cool. So look at libdb index.js.
Yeah.
Login, not in there. So it's not in there. So I'm going to guess it's a Lodash function. Let's see, Lodash login. Oh, that's just a utility library, Lodash.
Module, session service, session login. Let's see. Function login credentials. That's under services. Session.js, I think, is the one that we're looking for, because that's what just got passed in.
Sorry, I'm looking at my Atom, and all of a sudden it's just blank, and I think I had accidentally erased it.
Okay.
Anyway,
okay. So yeah, you can see how we can dive down into into the rabbit hole here, right?
Yeah.
Especially
no, dude.
List. Go ahead.
Look, go down to line 54. Go down to 54.
It's in that same. There we go. That's what I was looking for. I knew it was here somewhere, right?
Also, that's disgusting. Why is that there? Yeah, that doesn't make any sense. This should be the reason Seth thought it was in the DB was because he figured it was a library file for like data store stuff like ORM, which would be the normal correct way you would write an application. To do raw SQL in the same file as your logic processing happens. Is it a good idea? Nope. Terrible idea. That horrible. I mean, I can't even imagine why. So that's a SQL statement that then gets executed into okay. Yeah. So exec SQL. Luckily, it's not,
It's not SQL injection because it is using parameterized queries there. So we'll get to injection here in a little bit, but this is, yeah, using MySQL password. Okay, so at that point, this starts, like, I start to question, what does that actually look like as far as hashed functions go, right?
What's that permission length on like 92? Or not 90, sorry. I mean 90, comma, the word to TOO. Yeah, see permission.length is equal to 0. So that's an interesting. Anyway, sorry. We are going to go down a rabbit hole if we don't back out of this because it's interesting.
Yeah, so if I do a quick lookup on what is MySQL 5 password, oh, look, it only applies to MySQL before MySQL 5.75.5. Yeah. Let's see, password hashing mechanisms. Jeez. Doesn't even tell me what hash is being used, right? So this is something I need to note as a possible, guess what, this is bad, right? That's all that I have to know at this point, is that that's not one of the recommended password hashing algorithms, right? If you go look at the password or the authentication cheat sheet or password storage cheat sheet on OWASP, they're going to recommend PBKDF2 or bcrypt. They're not going to recommend MySQL 5 password. They're just not for password storage. So this is definitely a finding that needs to be pushed up in the authentication umbrella to the developers. So,
my goodness.
Okay.
This looks horrible. I'm sorry. I'm just like reading more and more through this thing. It's just not good at all. Yeah, man. It's like, wow.
Yep. All right, so that's authentication. Those are the authentication checklists. From a postmortem perspective, you can show the URLs for Django, log in, log out, like you'll see the different views here. We did already step through some of this, so we're not going to belabor that point. We'll just keep moving along. URLs.py has no references to login. We did figure that out. Django contrib auth, that's where it's all handled. And then this was the models. We've looked at all of this, so we'll go ahead and keep moving on. We'll get to auditing now. Ken, anything else on authentication?
No, just as my son would say, this thing is super sus. So interesting. But yeah, we got to move on because we've got 37 minutes left and we got to get through this.
Okay. All right. So my favorite topic, auditing, right? What is it, right? It's one of the Crocs and Socks topics of security because it's super
the dad version of security.
It's the dad version of security. I want to know what you did and when you did it. That's basically what it boils down to, right? If we're doing a review, we're going to look and see what the application actually tells us about what the users do. I'm always suspect when there's no logging in an application, because that usually means developers are depending on infrastructure components or the web server or something else to actually trace user activity. That's never a good idea because those components aren't going to give the same weight to the items that the application was built for. So in the case of Skia Django, right, like creating to-dos, updating to-dos, that's the whole reason the application exists. We probably want to call those out specifically so we don't have to do as many steps to figure out what users actually did, who the user was when they logged in, how they stepped through all of that. you've just got to validate that the appropriate logging exists. And I know it's super weird that I get excited about this, but it's because I've seen so many applications that do it wrong or don't log the right data, and then an incident occurs, and that's what's looked at as deficient, because every other component, security component that we have out there, logs to the point of just like overlogging, right, to death. And then we get to the application and the developers are like, I don't really care. Like, we're just going to move on from that, which is not what we want to see. So you've got to validate that it's there, that it's storing the right things. It's not storing sensitive data, right? Credit card numbers. Administrators have to trust that the logs may not be manipulated, right? So we can start talking about log injection as well. We'll leave that to kind of the injection piece, but you should be aware of that. Like, user controlled data being pushed directly into the logs is also a bad thing. Anytime some state is changed, that should be logged. The vulnerabilities out of OWASP top 10 are the ones that we're going to be looking for here: sensitive data exposure, insufficient data logging and monitoring. Debug messages, where do the debug messages go? Do they just go to like the console somewhere? What about error handling? Like, when those errors occur, you guys were talking, like Michael, you were talking about this, right? Like, failure messages. What happens to those failure messages? If it goes into the log file, like one of my favorite is, you'll be watching the logs, you'll see something in Splunk coming from an application, and it's like, user, Seth failed to log in, password 1. User Seth failed to log in, password 2. User Seth failed to log in, password 3. User Seth logged in successfully, right? So it's like you can infer what the password was based on what the information that was in the log file, and any developer has access to the log file, or there's people that could take over your account that have access to that log file. So that sort of information linkage is interesting as well. Sensitive data going into those logs. Information leakage. I mean, I know, Ken, you've dealt with this, haven't you? Like the fact that user objects being shoved into the log files.
Oh my goodness. Yeah. So like we've seen this where, exactly what you said. You expect a user, like the one example was the string being passed. It was supposed to be a string being passed into a logging function was user. And the idea was it was going to be the literal string, the word user, and then some additional very specific data. And by omitting some annotation, some character, it actually resulted in saying, not the user, the word user. It actually passed in a user object, and then like basically deserialized that user object. And it just basically exposed all the attributes of that user, of each user who hit that endpoint's information. But like the other thing too that's big here when we talk about information leakage is like third-party services, Datadog, something like that. What's the other one? New Relic, it's another big one. The thing is you really do have to be concerned about what is being logged where. There are certain things I would not at all feel comfortable logging to a third-party service. That's me and my comfortability level with how basically, if it's not in my control, I don't want to send something that because you got to remember, like that service could be completely fine, but like an account takeover happens on one of our engineers, account on that provider. And now someone out there has access to hopefully a restricted set of data that we understand what it's in, and we understand what's in it, and not like, tokens and like sensitive stuff and code snippets and stuff like that. So I'm very sensitive when it comes to like what we where we're logging, and then like really scrutinizing what's being logged.
Yep. Yeah, tokens is a big one, right? Like cookie values, session tokens, they end up in logs all the time. And the justification I usually see from developers is, well, I've got to be able to track this user from, log in to log out. And that's the piece of information that they're using. but the second that that gets exposed, or we start talking about Facebook tokens or something else, OAuth tokens, and like some of these values that are just long lived, it's an avenue for account takeover, especially when like Ken says, we get third parties involved.
But also there's times where people don't log things that need to be logged, right? Like specific security impacting events. You'll just see folks not even log, hey, unauthorized attempt, or, like, I don't know, some unexpected behavior, like not even logging at all and just doing, like, for instance, you and I had a assessment we did where the authentication function was calling off to some third party service. And so we looked at that third party service code and they did all the normal things. And then they had like this rescue exceptions block that just was commented out, like any of the actual exceptions, nothing would be caught. The code was there, it was just commented out. And like, we were like, oh, so literally no exceptions occurred. And then also it used this rate limiting library, but then didn't pass in the actual user information to like know who to rate limit. So it was like when you peeked under the covers, there were a few things bad there. But anyways, like, just not giving proper exceptions.
Yep. And here's another Java example. This is from actual code from a review. The problem that I have here, and I'll just step through and explain what's going on, is they give users the ability, like super admins in this case, ability to impersonate users. Now, the problem that I have is that it sets the org ID, registers success, tells like a response saying, hey, you switched over successfully to this user, but it doesn't actually drop any of this into a log file, right? That's a bad thing, right? From just an accountability perspective. And I mean, we notified the organization on this and they actually did fix it because they saw it as a problem as well. They didn't realize they had this gap in their forensic log. Is basically anything that the super admin did as one of the users, impersonated as a user, registered as something that the user actually did. So if the user was logged in at the same time, there was no record of which of the users actually implemented the functionality or made changes to the account without doing some serious just API scraping, like looking in web server and app server logs and trying to correlate it. But even then, it was a super difficult thing. So that's the issue that we're looking at here. We've got to call that stuff out. I think we've talked about a lot of this. These are the items. Yeah, go ahead, Ken.
I do want to throw in one other thing to mention here, which is understand when you see like .debug or .log or .whatever called that is effectively a logging, make sure you trace through and understand the library that you're working with. And if it's the framework or actually just regardless, understand if it will log in some certain circumstances and not in others. And what I mean by that is, most of the time there will be certain levels. So like you could have like .warn, .log, .debug, or you could have something entirely different, or you could have .log and then it passes in some parameters, and based off of those parameters, it'll only log in, say, development and staging environments, but not production, or vice versa. And that's important to recognize, is just like how that function occurs, or how that function should be called. And then at what environment, like will it execute in all environments? Will it only actually log in certain other ones? Is there a log rotate? Like sometimes there could be a situation where you every time you spin up and like push new code and say that the server restarts, it overwrites a log file. That's happened. So just understand like how those functions are supposed to be called, and then what environments, literally like development, production, or staging, they will execute in.
Yep. Yeah. I mean, some of this pushes into kind of like CI/CD pipeline checking and configuration checks for those logs. And we'll get to some of that tomorrow as well. But realistically, you've just got to be aware of what's being logged and why we're logging it. And I do love, Michael, the logging the username. where somebody mistypes their password into the username field. Yeah, that never happens. No one's ever posted their password in the Slack, right? Ever.
I did that today. So
yeah, there you go. That's always a fun exercise in crap.
Private channel, private DM, but yeah.
Sure it was private. Yeah.
I'll just tweet it.
So these are the questions that you want to ask yourself as you're going through the logs as they're being generated, right? Are they specific enough to reconstruct events? Are they configurable through settings? Are they hard-coded in source? Is the user controlled data validated or sanitized, right? To prevent that log injection. It's kind of a crossover.
I was going to talk about the configuration, but you just mentioned it. And so while we're here, when you say, is it configured through environment variables? Whenever something is dependent upon an environment variable, I've seen this with session secrets. I've seen this with things like this, like the logging bits. You know how sometimes it'll say, like, speaking of, like, by the way, what environments things are executing in. Like maybe there's a environment variable that says that it's supposed to be production, but if that environment variable didn't get pushed up, then it like defaults to maybe development. I see this all the time where people will just be like, oh, do something if this environment variable exists, with no catch-all as to how honestly, you shouldn't even have a catch where it's like, oh, revert to this other value if this environment variable isn't included. And that goes for anything. It's just not just auditing and just session secrets. And I was, like I said, I was going to talk about it in configuration. But if a variable isn't there, it should just raise an exception and not start up. You do not want your applications to continue executing with missing environment variables just because it defaults to like, the pipe, some other value. So anyways.
Yep. That goes back to the JWT, null issue that we have. Like it's failing open instead of failing closed.
Right.
This is just an example of an error message, like logging that error. I think, it's not a bug actually there. It was just showing how to do it. Okay, so that brings us to Abraham Lincoln. Let's look at, let's build an auditing checklist, review a couple items there. So just build one or two for that. And then Behemoth specifically, let's look and see if we can figure out what the logging mechanisms are. If they are logging, see if you can find a couple examples there. I know we already mentioned Morgan. I think that has to do with their logging mechanism. They have changed it over time, but see if you can identify that. So pull out a couple auditing items for Skia Django and then do a couple for Behemoth. Let's take, I say only 10 minutes on this, Ken.
Yeah, we don't, because then 8.
And then at least we can talk about injection. We may end up doing the exercise tomorrow morning on that. But at least we can talk about injection. Injection is a large security item. So let's take 10 minutes and then we'll bring it back together and walk through the auditing checklist for Skia Django and Behemoth. Everyone ready, set, go. All right, I know we're not giving everybody enough time to step through all of these, but let's talk Skia Django auditing checklist. Number one, or actually, give me something that you were looking at. Like what is a risk? What is a checklist item that you wanted to look at or you did look at? Yeah, log formatting. Awesome. Sensitive info and logging. Good, good, good. So there's a couple of good items in there for sure. And Mike, you caught that maturity. Yeah. Yep. See if there are logs for it, like event to do changes. I mean, it's a pretty simple app, so there's not a lot to it. But the settings.py, you'll notice that there's a logging section, right? Okay, that's pretty interesting. There's a handler, this logging file handler, but he caught that this was the formatter was simple here for the handler. And what does the simple have? All it has is a level name and a message. It doesn't actually have this ASC time. That's a bad thing, right? That means that we can't actually track any of these message items to a specific time when it actually, when the item happened. And then we can check through each of the different views for Django to see if, let's see, that's under intro. Intro, views, yep. To see what's being logged, logger.info, get to do. All right, looks like we're looking it up. Somebody pulled a to-do item, somebody updated a to-do item. Now, the one concern that I have here is with the request.user.username, right? Is that something that's updatable or is it controllable by the user themselves? What happens if they put a return character in there? There's some log injection that could possibly be going on with each of these spots where request.user.username is being called, because we are just passing it straight into logger.info. Get to-dos, get completed to-dos. It doesn't look like we've got anything in sign up for login, but most of the items do seem to be covered. So as expected, right, with a simple application, it shouldn't be too hard to drop those all in there. But things like password changes and to-do change and log in, log out don't seem to be going to the log file. So there is a deficiency there that we probably need to note. Good call. We'd be looking for the same thing in Behemoth. Did anybody get to Behemoth to look? I know we only gave you like 10 minutes, so if not, that's cool. Mike, what did you find? Ken found a sigh. That's about right.
Oh, I'm sorry. I thought I was muted. I'm yawning over here. I told you it's a long day.
Commented out code for fetch report. Interesting. Yeah, if we're looking, I mean, debug process. Okay, so there's debug logs that are going on and being dropped out somewhere, right? But that looks like just like configuration. There's a section on deleting entries. Okay. Well, let's look at one of these controllers, right? Actually see if there's like an admin controller. This sounds like a good thing to look and see. Last like lookup user. Okay, this is all back-end functionality. I'm probably diving a little too deep there. But I mean, auth.js is a good one, right? The user's logging in. There's the async function that's there, but we're not actually logging a lot of information here, right? I'm seeing that as missing, that the user logged in successfully. All we're doing is, generating, has authorization. Like we return error messages, but we don't actually log that information anywhere that user successfully logged in. So that is an issue in and of itself. Okay, so Morgan's the npm HTTP logger. Great, but I don't know how much is actually going to be in there. Yeah, significant events. Yeah, so it doesn't look like it. There's a lot of thought that's been put into logging. This might be a case where I'm writing like a single finding that is just like insufficient logging for the whole application, and tasking someone in the development community to go in and actually figure out what needs to be logged and in what manner, or if there needs to be another mechanism that does that. The other thing that we could do is implement an interceptor, right, via Express to actually handle the logging for us for specific items that we're interested in. That's kind of a band-aid if we're not in these actual files where the sensitive data is being passed around or the sensitive functionality is going on. Cool. Good finds, everyone. Looks like logs are placed in the database. More compliance reports. Nathaniel, where were you seeing that in Behemoth?
I was actually just searching through a lot of things, trying to go and find like any instances of Morgan logs, logger, the info debug, those types of things. And it just looks like there's a lot of I found more of where it was generating the reports for those and like the HTML than I was where it was actually storing information. And it looked like it was in like the inventory and financial type things. So it was more the compliance logs than it was like a forensic audit log type thing.
Interesting. Yeah. I mean, you think about a hospital administration system, that's probably more what the developers are concerned about, is that functionality to expose the financials and the patient data to compliance or HIPAA people, rather than the information system itself and what's actually being logged there. So it's definitely deficient in that aspect. I'm not seeing something that's comprehensive across the board. So we're going to have to take a step back and look at it. Now, I know that's not the sexiest vulnerability, right? Like, it's a dad vulnerability for sure. It's Crocs and socks, but it's one of those items that, when it's done well, is incredibly useful to the business in general for any application that is sensitive, that has sensitive functionality or data for the business. Like, we dump that application data into Splunk or something like that, we can build reports on it. And there's a whole bunch of other security indicators that go into that can be very helpful in knowing whether or not you're being attacked. So it's an important point, even if Ken does make fun of me for being Crocs and socks. So, let's see, I think we looked at the sensitive functions. Yep, create to do, and we're actually looking at logger info. File name info.log, but yeah, we were doing the simple format. Okay, so crap, man, we've only got 6 minutes left.
Yeah, I think it's probably useful to just run through tomorrow real quick, as a recap. So today the goal was, and actually let me stand up while I talk. So the goal was today to kind of just get to a point where we've given you the first steps of like getting to know an application, and going through some of the checklists is, necessary, because we have to explain like why we put these things into a checklist, have you do exercises using those checklists. We'll continue that tomorrow with injection, cryptography, configuration. And then what we'll do is we're going to, as I said this morning, we're going to walk through together. So I'll drive, because frankly, Seth developed the virtual task manager, the VTM application. I've done this exercise like a number of times, but I never remember, and it's always different because you all are driving. I'm driving, but you all are giving input as to where we go. So my hands are on the keyboard, but y'all are helping to lead where this goes. So I guess what I'm saying is I don't really know the application that well. So it's actually like usually really good, because it's pretty close to what it would be like in a real, in a real review. So we're going to walk through this methodology end to end. Today, we broke it up into chunks, exercises built upon each other. There was a lot of talking, a lot of information to absorb. Same will be true for first thing in the morning, or I guess not first thing in the morning, but right when we start the course. And then, like, as I said, with VTM, we wrap it up all together. So you get to see what this all looks like. It's really fun. It always is fun. It's a good time. And then after that, we usually break for lunch. And then when we come back, we'll have, we're going to figure out how we're going to do the breakout rooms. But that's what we'll do. We'll effectively have breakout sessions for you all. You'll pair up. And then, as I said, there should be time left to cover your notes and do a presentation on somebody will be the driver and show what the team put together. And yeah, that's kind of what we'll do. And you can see what, I guess, why that's always fun is it's very interesting to see, using real applications that people download off the web, just how far they can get if they follow a process in just like an hour or two. It's incredibly, you'll be surprised, I think. So
yeah. So I mean, we'll wrap up the checklist first thing in the morning. So what's Ken saying? We'll step through VTM, he'll drive, and then there is the functionality in Zoom to have these breakout rooms. We'll probably do 2, maybe 3 people per breakout room. We'll just go ahead and sign those randomly. You'll pick a project, you'll use the process against it. Ken and I will pop into the breakout rooms and help out as we can during that session in the afternoon. And then last hour will be presentation of what we've actually found, just to give everyone hands-on, jumping through some interesting things. So your task for tonight, as you're, doing whatever you're doing, like in between class periods, is to think of open source projects that you would think that you would want to assess, right? That you would want to look at the code and see how they're doing and doing the stuff that we talked about today: authorization, authentication, auditing, injection, to see if you could find flaws in it. There are a lot of complex applications that are out there, right? Like, I probably would say, let's not look at Apache, right? HTTP or HTTPD or something like that. Let's pick something that's a little bit more approachable. We will have a list that we will provide tomorrow if you can't think of anything, but pull out your favorite, messaging site, or, there's a lot of sites out there that release their code as open source. Look on GitHub, maybe do some research, and come prepared to do that tomorrow. Good. So that leaves us with like 30 seconds before the end of the course today. Any questions about what we've covered up to this point, or what we're going to be doing tomorrow? I know it's a lot. We're throwing a lot at you. Ken did post. Ken, will you post up the link one more time for the slides so people can look at it if they want to tonight?
Yeah, sure. Yeah, no.
I think we did drop them up there, right?
Figure out how the internet works real quick.
We have been going for a while, so
yeah. Handouts. Yeah, so it's under. Did someone post it? Is that why you said there? There you go.
No, I just found it, right?
Oh,
so.
I gotcha. I was
that didn't actually work though.
Okay, well, let me put it. I'm going to put it in the Slack channel right now. And like, I could put it into Zoom, but since we're closing Zoom, it's not going to be there. So I put it in Slack as well.
Okay, sweet. All right, so check Slack. It's in there, and yeah, let us know if you have any questions. But otherwise, we'll see you right at bright and early at 9 a.m. Pacific, or late for you, depending on where you're at. I appreciate all the involvement today, and yeah, we'll talk to everybody tomorrow. Thanks, everybody.
Thank you.
Thanks.
Thanks, guys.
Bye.
Have a good night.